Okay, so the data extraction is performed step by step. We have to develop a form that we use to collect the data we are interested in from the studies. And yesterday I emphasized the fact that this form should be developed quite carefully with your team, and it should be piloted. You can take a few studies to see how the form is performing. Then you can um, revise it and get it ready before it is used to collect data from all the studies included in the review. So once that is ready, the data extraction is done in pairs. So each pair is doing the same thing independently. And once you have finished doing that, you come together to compare what you have extracted, resolve any discrepancies, and then have a uh, so you um, have a consensus and develop one data extraction form you can take forward. And then from this data extraction, you will get the information that you will include in the tables you have included in your review. And then we discuss the issue of quality appraisal or quality assessment of risk of bias assessment, however it is called, or which term you choose to use. They all mean the same. And I highlighted the fact that this is the stage in the review where you now want to appraise the quality of the included studies. And the quality of the included studies um, helps us to understand the level of confidence we will have on the evidence we have generated. If the studies are of poor quality, so regardless of the results they have produced, the confidence is low. And so the process that yields the results is important. The study design, is it appropriate? The measurement made in the study, have they been done in an objective way? Have they used the right tools? The way the analysis have been done, the conclusion that have been reached, are there conflict of interest, and so on and so forth. So these aspects need to be considered alongside the evidence the study has generated. Um, I also demonstrated and showed to you some of the tools that are used for quality appraisal. For clinical trials, I suggested that you use the Cochrane tool to do that. That is the best so far. And then for observational studies, all kinds of different studies, go to EP, HPP, or the CASP tool, or Newcastle or Tower. There are several others, but these three I think are commonly used. And if you go to their website, some of them have tools, for instance, for qualitative research or diagnostic research, and so on and so forth. But the key thing here is that the quality of the study uh, needs to be appraised. And then we discussed the issue of synthesizing the evidence that you have now collected using your data extraction. You need to put everything into a meaningful way that can be informative and helps people to understand what the topic you have performed your systematic review, what the conclusion is. And so in doing this, I highlighted that there could be two approaches depending on what the evidence you have is. could use narrative only, in which you use text, because it is not possible to use statistics to analyze the data. You use text only. And I mentioned that there is no gold standard in doing that, but you can have a framework in which you describe what you have done, what the evidence is. And in doing this, it's good to tell a good story. It's good to reach a good conclusion. It's good to have the audience in your mind when you do that. So you do it in a way that is understandable. Then if from your assessment, you decide that a meta-analysis can be done, which is the quantitative synthesis, then we went through the principles of meta-analysis, which is on the premise that bringing the studies together takes us closer to the truth than just using evidence from one study. And in doing that, we went through the different approaches. There are two approaches to performing meta-analysis: the fixed effect method and the random effect. And we discussed, of course, some of you found it challenging yesterday, but I highlighted the fact that the difference between them is the assumption they make towards the studies you are including. The fixed effect makes the assumption that all the studies are similar or identical. And so the only difference that it's in those studies is as a result of the random error, the selection mechanisms that led to the recruitment of the participants. So if you increase the sample size of each study, you remove the random error. But we know that is not how our world works. Things are different in different ways. And one of the questions that came yesterday was, in which context you use fixed effect? And I also described that even in situations where you do multi-center studies or multi-center clinical studies, clinical trials, where you use the same protocol, contexts are different, and different situations are different, that even making this assumption that the fixed effect makes is also challenging. And then yesterday, one of the things I tried to do was to convince you that the assumption the random effects makes is close to reality, and try to convince you that when you do your meta-analysis, go for random effects. If there is a difference between the studies, you'll be able to include that difference in weighting the studies. But if there is no difference really in the studies, then the random effects will usually be equivalent to fixed effect. And so the assumption is what separates them. And this assumption leads to the weighting mechanisms that are used to combine these studies. So once you have made a conclusion of the approach you use here, and then you perform the meta-analysis. So this, in a nutshell, was the issues we covered yesterday. So I just give this room if there are questions you have had between yesterday and today.
Dr. Bright, good morning, sir.
Good morning.
So it's not a question, but I wanted to clarify if we have a sample of the data extraction form. So I was looking at the Dropbox, couldn't locate if we have a sample of the data extraction form, something to guide us to develop ours.
Yeah, I put the data extraction form I showed yesterday is in the Dropbox. I put it there. Well, during the next break, we will go. I will check exactly where it is, and I will let
It's
you
okay.
know.
Okay, sir. Thank you, sir.
Yes, Urban, you have a question?
Yes, supposing the course of the design was very inappropriate and perhaps with lots of bias. Should that not be enough reason perhaps to even exclude that study?
I didn't
Yeah,
get
you
it.
may have included it ab initio. Yeah, the study may have been included ab initio because of the title and perhaps the abstract. But if you now go into in-depth study the design and all of that, and you find it to be inappropriate and lots of bias, can you at this stage still exclude the study? Should I say it again, sir?
I can. Your line is not so good, but I can get some of the things you have said. So you're saying once you're doing your screening, and then you have included a study, perhaps based on the title or the abstract, and then you continue to go in the process. Maybe when you get to data extraction, you discover that the study may not be relevant to your review. If you can exclude it at that point, is that what you're asking?
Yes, sir. In view of the large amount of bias you find in the design and in the sampling, perhaps can it be excluded, despite having good results show?
I will still emphasize this, Urban, and for every one of us, that if we go back to the first day, when we defined systematic review, you found that the Wikipedia definition was saying a synthesis of all high quality studies. And I mentioned that because of that, the Wikipedia definition is deficient, because the goal of a systematic review is not to find the high quality studies and synthesize those. The goal of systematic review is to synthesize all the relevant studies on that topic, and then through that we can separate those that are of poor quality from those that are of high quality. So you don't exclude a study at any stage because of loss of bias. That information is needed for you in the synthesis process to highlight the level of bias that exists in the studies. And so when you go through the quality appraisal stage, it is at that stage you are able to give the quality statement for every study. So this study you're mentioning now, if it's deficient in many ways, so each component you are praising the quality, we eventually receive low grade of quality.
Okay,
Is
that's
that clear?
correct. Thank you.
Okay.
Thank you.
Any other question? Please ask. Do you have any question?
Hello. Yeah, Godfrey here.
Yes, Godfrey.
Now, we did not emphasize about the PICO. I know I did with the Manchester Metropolitan University a PICO review, which uses the SRA and the methodologies and the merits and demerits in terms of and we did not go to the MA part of meta-analysis. Can you highlight of course, the P for population intervention and the C and O, where we can capitalize opportunities around the PICO to summarize our tables for yesterday's assignment? Because I kept doing this and then I was reflecting back on what I was doing. I was just taking journals which I need to use, the ones we are eliminating, or the ones that could be potential for inclusion, because you might realize that there are some journals you reject, but eventually you realize they also captured some few points in the conclusion. So can you reflect on some few comments on that?
Godfrey, I didn't get your specific question, but if you're asking about the PICO.
My question is on the PICO. That's the question.
If you're, so this was the point we made on the first day. And
yes,
the key thing here is that the first thing you do when you do a schematic review is to define the topic you want to do a schematic review.
Correct.
And in making that definition, you need to ensure that different components of the topic are included.
Yes.
So that you'll be able, because in the way this is done systematically, it's good to define the components in a way that when you search the databases, you have efficient searches without missing the studies that you should have included, or without overtly including studies that are not relevant as such. So that is why we need a framework that will help us to define our question. And the PICO is a framework that people use. It's one of the frameworks that people use to define their questions. And I mentioned that PICO is much more relevant when you're doing studies that are looking at association, cause and effect, studies of exposures and outcomes. The PICO is much more relevant. But even when you don't have association studies, some aspect of the PICO may not be relevant, so you can take the aspects that are relevant to your study. So it's a framework, and what it does is that it helps you to develop this question. It helps you to ask yourself, who are the participants I'm including? For instance, children, the P, adults, or the whole population. It helps you to realize that. It helps you also to realize what is your intervention or exposure. Yesterday, I went to some of the groups, the breakout groups, and I think that was helpful for some of the groups to help them to think through how they have defined their questions and how that influences what they actually do in the searching. Because once you have the PICO and you identify your population, the intervention or the exposure, the outcome, then it helps us now to be more specific in collecting the keywords that describe these different components. And so once you collect those keywords, you can now implement your search in an efficient way. So PICO is a framework, and you do it, and when you do the search, you retrieve your studies, you export, you screen. Then when you are trying to report, of course, it's not limited. Your report is not limited to the PICO you have given there. I showed a table yesterday that this student has used in describing the characteristics of the studies. So there are
Mm.
different components you can include in your report. But what the PICO does is to help you to get a grasp of your question, helps you to dissect that question into different components, helps you to develop the search strategies that will be able to retrieve the studies that address that question you're looking at. So I don't know if this helps.
No, it helps, and I'm very clear. I wanted just to highlight that because some groups might not know this. I did a PICO, and I found that it helps even in the data analysis and even in the quality assurance when we are doing the other part.
That is right. What you're saying is right. And
yes.
yeah, I mentioned in the first day that if you get the question wrong, it affects the other stages you're doing.
Yes.
If you get it right, it helps you to do the other stages well. So yeah, it's good to define that PICO appropriately. Then the other stages will not be challenging for you.
Thank you.
Okay. Any more questions?
Yes, question, please. A little bit not too conversant with the fixed effects with the random effect of meta-analysis. It's not too clear in my head.
Yeah. Okay. Any other?
There is statistics, but please, I know you can make it much better today.
Okay. It looks like you missed our
yes.
revision for today.
I missed it. I was doing something.
Okay.
I'm sorry.
All right. So I was saying that when you have collected the data from the studies, the next thing would be to synthesize this data to reach a conclusion, to tell the story of what you have found from the systematic review you have undertaken. So once the data collection is done, the next stage will be to synthesize the evidence. And the first day, I mentioned that meta-analysis is the statistical part of a systematic review. Meta-analysis is not equivalent to systematic review. It's a part of the systematic review. And it's a part of the systematic review that you use statistical methods to combine the estimates that come from the studies you have included. So after collection of data from the studies, you synthesize, and the synthesis can be done using narrative approach. And in that case, you have made assessment that a meta-analysis is not appropriate for me. But if you decide that a meta-analysis is appropriate, you can do it due to the assessment of homogeneity of the studies. Then there are two approaches you can use to combine this estimate. The first approach is fixed effect, and the second approach is random effects. The fixed effects approach is assuming that the studies you have included are identical in their estimation. So the studies are identical in every way. And so the only difference that exists between the studies is the selection mechanism, or how the patient or participant have been selected into the study. And so if you increase the number of people in the study, then you would be able to remove the differences between the studies. But yesterday we mentioned that this assumption is quite challenging, because when people are doing their studies, there are different factors that come into play into each study that will affect how a study is done across places. And so if we take the assumption of fixed effect and use this approach to pull our data, we're making a strong assumption that may not be realistic. But random effects approach to pull the studies relaxes this assumption, saying that because of the differences that exist in our lives, in reality, in the methods we use, we can't assume that these studies are estimating the same thing and they're identical. So it will be good when we are doing the meta-analysis to account for the fact that studies are different. So for that, the random effect in combining the studies adds a component that considers the differences between the studies included there. So I went further to say that if the studies are similar, the random effect will usually be equivalent to the fixed effect approach. And so you lose nothing when you use random effect. Just use it, because whatever happens, you will get the right estimate. If there are no differences, you will have exactly what the fixed effect would have done. But if there are differences, then random effect will identify that difference and use that difference in putting the studies together. I don't know if this in a nutshell.
Better.
Okay. Is there any more question? We can take one more before we go for. Any question? Okay, so I think we go for 10 minutes break. Let's come back at 40, and we'll go to the our assignment. So what I will do, please don't log out. I will put you into your groups so that when you come, you go straight to your group. So let's come at 40 and don't log out.
It's around 10 minutes break.
Hello. Bɛsɛ yɛsi mu bɛsiesie ansa na yɛaba na mebaa bɛyɛ adwuma wo bɛtumi afei a menyɛ dɛ
mefiri a mekikira makɛsiesie bia na ɔfisi
Okay. You were able to get my email in the evening yesterday. So what I want you to do, and I guess you have read the section I highlighted for you to read, and you have seen the instruction of what you are required to do now. So you take 10 minutes within your group, and you look at the section you have read, and you can discuss and harmonize your views and come back so that we can look at this activity. Okay, let me send it to your rooms now. Nemo, what group are you?
In group 5.
Group 5, okay. So you can join your group.
I'm a little bit because if you look through the, let's see, if you look still have to interpret the figure, what is it? Figure 2, which is the forest plot of association. I'm not sure about the weight because the weight is quite variated.
Rosa,
Yes, we have small weights, but then we have hundreds and
Rosa,
15, which it doesn't tell us.
Wow. Interesting.
interesting. Okay, let's go back.
Yes, automatically fine.
Okay.
Did it the first time.
Okay.
Okay, you're all back here.
Yes, sir.
Let's go straight to group one. Please just use 1 minute. Tell us the title of the paper and tell us what you observe. Have they used the right meta-analysis method or not? And why do you think they have used the right one or not the right one? I think that should be
This is
done in 1 minute. Yeah.
This is
Group one.
Yes, group one.
Mm-hmm.
Can you hear me?
Yeah, we hear you.
Yeah, we are looking at a meta-analysis of interleukin 13. Interleukin, okay, 13 monoclonal antibiotics for uncontrolled asthma. And we looked at the methods section and we found some shortcomings in the method section. Now the writers indicate that they searched PubMed, Cochrane.
No, I don't want you to describe that. I want you to look at the statistical analysis method. What type of meta-analysis have they used? Have they used the right one or not?
No, it's actually it's not clear. When we look at the statistical analysis method, it's not clear here because they said they would use the fixed analysis method if there was no significant heterogeneity. And then they go ahead to say they will use, that random effect model would be used if there was significant heterogeneity. So actually, don't make it clear as to what exactly they did.
Okay, that's fine. So let me explain this for everyone. I mentioned this yesterday. I mentioned the fact that many of the authors don't use the methods based on the assumptions the methods make. What you have mentioned there, you see it in many papers, that they tested for heterogeneity. And if they found significant heterogeneity, then they use random effect. But if there was no significant heterogeneity, they use the fixed effect. That is the wrong approach to take, and it's not right. I will emphasize again that you choose to use fixed effect and random effect based on the assumption you're making on the data.
Yes.
And I have said, just go for random effects because the fixed effect is difficult to meet that assumption. And more so if you are taking your studies just from the literature as we do for our projects, searching the databases, use the random effect. You have no justification to use the fixed effect. The issue of heterogeneity is the next topic we cover. We'll come to that perhaps because we have not done it. That is why you were a little bit confused. But what the authors in that paper have done is that they have performed a test of heterogeneity, and they have used that to make a choice whether to use fixed effect or random effects, which is the wrong approach. We'll come back to that. Okay, thank you very much. Let's go to group two.
Okay, thank you very much. Our paper is titled Olive Oil in the Prevention and Management of Type 2 Diabetes Mellitus, a systematic review and meta-analysis of cohort studies and intervention trials. Now, random effect meta-analysis was used for this study, and it is appropriate because there is a presence of heterogeneity, which existed first in the study design. The study design, they used two cohort studies and interventional trials, especially the randomized control trial. And there is also heterogeneity in the study size. For the cohort study, they had 15,784 cases. For the randomized control trial, they had 29. And also the number of studies also varied from 4 studies to 25. The number of cases also varied from 40 to 19,081. So, so in that, we're concluding that since there's some sort of heterogeneity, so using the random effect meta-analysis, we'll distribute the weights, equally.
Okay. If I come in here, these justifications you have given, were they given in the paper why they chose to use random effects?
It was
or,
not
this is your
clearly
own
stated. Yes, it was not clearly stated in the
okay,
paper.
but
Yeah,
you said that they use random effects.
yes, they used. Yes.
Okay. So
Yeah.
yeah, and you think this is appropriate?
Yes, sir. Based on the criteria you have given, and we picked them out from looking at the meta-analysis of the work.
Okay, thank you very much.
Although it was not stated clearly why they chose. Yeah.
Okay. Thank you. So this is another example where the authors have done the right thing, because yeah, the random effect is the right choice to make, and they have made that. In many cases, you will not see justification for using it. Of course, you don't need to make such justifications, but you can already see that once authors have searched the literature, or even when they are doing individual patient meta-analysis, it is good to use the random effect. So just to give you a perspective that a lot of things are happening in the literature. People are making different choices for different reasons. So the essence of this course is that we use the right methods because we believe that is the right method to use. Okay, group 3. Group 3.
Thank you very much. Our topic is, the title of the article is shift work associated with a higher risk of overweight or obesity, a systematic review of observational studies with meta-analysis. The researchers used a random effect model to pull the effect estimates, because they basically used 26 studies, which included 7 cohort studies, 18 cross studies, and 1 case control study. So you would really identify the heterogeneity in the studies, a little bit diverse. And they also identify that to measure heterogeneity, they use I-squared. And when we continued to read, we identified that even in the conclusions, they identified that the heterogeneity was quite substantial, because papers were a little bit diverse from each other, though it was very, the results were relevant. So
yeah, so they use random effect, you said?
Yes.
Okay. Then when you look at these papers, you found that there are actually differences, and so
yes.
they have used the appropriate method.
Oh yes, they did.
Okay, thank you very much.
You're
Let's
welcome.
go to group 4. Group 4.
Yes. The title of the paper is Association Between Antiretroviral Therapy Adherence and Employment Status to Systematic Review and Meta-Analysis. And here they use the random effect model. And I think that they assume there is heterogeneity in between the studies. They have like 28 studies. 4 of them, they were cohort studies, and 24, they were cross-sectional studies. They have like different populations. They analyze like in high, middle, and low income countries. They also have difference in the method they use to see the adherence. In some studies was self-questionnaires, in other was measuring the drug in the blood. So they have like many, their heterogeneity in between the studies, and that's why they use, I think that's why they use this random effect. Also the sample sizes were quite different in between the studies. So I think that we think that they use the right method.
Okay, thank you very much. Yeah, group 5.
Okay, this is Josephine for group 5. Our paper was on the impact of point of care C-reactive protein in ambulatory care, a systematic review and meta-analysis. In our work, they use the random effects, and then they justified it using the I-squared test statistic. But from our discussion, we are justifying the fact that the use of RAMA is the right meta-analysis to use because there was a lot of heterogeneity with respect to the sample, the population they used. They had a combination of studies where sometimes it is only adult patients, sometimes it is only children, and in other studies, it is a combination of adults and children. Additionally, they had a combination of randomized control trials, individual studies, and then some observational studies. So looking at these study designs and even population groups, we think that it is good to go for the RAMA rather than the FEMA as they had used in their study. Thank you.
Okay, so that is a study that used similar approach as that presented by group 1. Yeah, they have used the random effect, but you said they made the decision based on the I-square value. And then that is the wrong thing to do. And that is why I gave this activity for you to realize that sometimes people use the fixed effect when it is inappropriate. And sometimes when they use the random effects, they use the wrong decision to use that. And this paper, yes, has used random effects, but using it based on the I-square is wrong. The premise is for us to make the right assumption. The papers were included in our review. Even before testing the I-square, what is our assumption on it, on those papers? Are they identical? Can they really be identical? They will always be different in some aspect that we may not even know just, just reading them. So the key thing here is that the fixed effect approach has an assumption it makes for you to use it. And the random effects approach has an assumption. And before you put the studies into the meta-analysis, you need to decide on this to ensure you are making the right assumption on the studies you are including. And once you have made that assumption, what the I-square does, the I-square is not to help you to make the assumption. What the I-square does is that once you have made the assumption that these studies are different, what the I-square does is that it helps you to account for those differences that already you have judged that are there. That is what the I-square does. And from there, you can now ask the question of what could be explaining this level of differences I have identified. And you can evaluate it further. We'll come back to that in the next session, but just to highlight the fact that the paper group 5 has presented has used the right approach, uses random effects, but the justification for using random effects is wrong. And we shouldn't make that justification. Once you have finished from this course, don't make the justification that I've used random effects model after I observed that the I-square was large. Don't make that assumption because it's wrong to do that. Okay, last group, group 6.
Thank you. This is group 6. The beautiful thing is that the observation you have given for group 5, follows suit for group 6. However, the title of the paper we examined is Impact of Point of Care C, Reactive Protein in Ambulatory Care, a Systematic Review and Meta-Analysis. And just like I said clearly, the same observations that group 5 did is what we have. This paper also followed suit. So the random effect was done first before the I-square, was put to test. And then of course, The paper also showed a variation in terms of the population that made up the final studies that were examined for this analysis. From a database that yielded 26,000 records. And then, of course, it said after assessment, only about 225 were included in the study. So that showed that for the meta-analysis from 26, that which was considered was quite small. So you can be rest assured that the output in terms of what is required will also be low. And then, of course, like I said, there is also variation in terms of the population for the study. In some cases, they had adults. In some cases, were children, and so on and so forth. Thank you.
Okay, thank you, Jonathan. I think you looked at the same paper as Group 5, and that was
Yes.
my mistake in the first day. Perhaps you have taken the papers out of the Dropbox before then, but I changed the papers because I made a mistake by including the same papers for Group 5 in Group 6.
Oh.
So I changed that. So you should have had a different paper for your group assignment.
Sorry.
But you
The
can
moment
rectify
you
that.
dropped, I just downloaded group 6 folder. So I
Yeah.
rectified
So for tomorrow activity, you should have a different paper in your Dropbox you will be using.
Okay.
So if you use what you have downloaded before, you will still have the same paper as Group 5, but you can rectify that to take the new papers I've put for Group 6 there.
Thank you.
Yeah, so that is the same thing we have said here, making the right assumption before you do the analysis itself. And that is when you have done your data extraction and done your quality appraisal, you should have a clear picture of what the studies are, and then you can make the right assumption. But like I said yesterday, always go for random effect, because the fixed effect assumption is really very difficult to meet if it can be met in reality. Okay, let's take a short break again and come back at 20 past, and then we can go into the activities for today.
Good morning.
Okay, I guess we're all back. Then we need to continue. Before we start, I would like to say that the in-class activity for tomorrow, as you could see, the ones we have done so far have concerned only aspects of the studies. So for the in-class activity tomorrow, the skills now you have learned, you will now put it into practice. So the goal of that activity will be for you to take a piece of systematic review that has been carried out, read it from beginning to the end, critique it, using the knowledge you have gained to see if the authors have done it well. If, for instance, you are a reviewer for that journal, there, even though the paper is published, of course, it has gone through review, but can you see things that would have been improved or things that were not done appropriately? So that would be the goal of the in-class activity for tomorrow. And I think this would be helpful for you to see how people are also reporting what they have done. Okay. The second thing is after lunch today, we'll get into doing the meta-analysis. I know most of you are waiting for this. So please, the things we have studied yesterday and the things we'll be doing this morning, we'll demonstrate them by doing the analysis. And I've said we'll be using RefMan. So if you have not downloaded RefMan, please get it ready, because we'll be practicing it. I'll be showing you and you will be seeing it and doing it yourself. Then the final thing is the data extraction form. I sent a message to the chat. I have now put it in the landing page of the Dropbox folder, and also it is in a subfolder there where I put it before, but I've also brought it to the landing page so that you can see it. Okay, do you have any question based on the activity we have just done? Okay, if not, so this is where we are. Yesterday we covered this, and we went into the synthesis part and the interpretation. And it was here we covered the meta-analysis. And we'll continue to this morning to explore some of the things that may result when you do your meta-analysis. You begin to evaluate, because the goal of the systematic review and the meta-analysis is for us to reach a satisfactory evidence synthesis. Our conclusion should be clear, should be exhaustive. And so it means that we would have evaluated different scenarios that will come. It's like when you do your normal statistical analysis, you try to evaluate to understand what could be explaining my results. Are there extraneous factors that could be influencing my results? So you do the same thing here. It's a step-by-step approach. So we'll be looking at some of those issues this morning. The first one is heterogeneity, and this terminology has come up since from the first day we started, and it's a terminology that remains there because we are bringing different things together. So this term becomes important. And heterogeneity in the studies is just any type of variability, any type of difference that exist between the studies that we include in our systematic review. But at this point now, we are looking at the heterogeneity when we are doing the meta-analysis. Okay. Okay, so I mentioned, I think 2 days ago, or yeah, that this can manifest in what we call clinical heterogeneity. And that is differences we find in terms of the characteristics of the participants between studies. For instance, if you include people in studies that have, if there is a disease, for instance, you're looking at, and there is a spectrum of severity of this disease, a spectrum of severity of this disease. And we say, for instance, this spectrum is stage 1 to stage 4. And you collect studies that have investigated this disease. And the different studies are looking at the different stages of the spectrum of the severity of this disease. That already is, to an extent, an indication of clinical heterogeneity, because the patients suffering from this disease coming from different studies are not on the same level of severity. So differences in participant or patient composition may cause clinical heterogeneity between studies. For instance, you're combining children and adults, you're combining in terms of race, black and white, you're combining African and Asian together. So those are aspects, but this depends on the question we are addressing. It could also be in the intervention, how the intervention has been done, how it has been measured, how the intervention has been defined. So this is that, and the outcomes as well. How the outcome has been measured, has been defined, may vary between studies. Once you begin to do, and I guess from what you are doing in your group project, you see that this is manifesting as well. So this is the level we say the studies are clinically heterogeneous. Methodological heterogeneity, I mentioned also this the first day, and this could come from the study design, the risk of bias, and the different processes that result into performing the study. So this is the aspect of methodological heterogeneity. Statistical heterogeneity. These two combined will result to statistical heterogeneity. And when we do the meta-analysis, it is this that we estimate the statistical heterogeneity, which is a result of clinical and methodological heterogeneity. And that is why I said it's a consequence of clinical or methodological heterogeneity, or both. And this is what we estimate in the meta-analysis we do. Okay. We are back to the forest plot again. And these are two forest plots. How do we detect heterogeneity when we do our meta-analysis? What is the evidence there is presence of heterogeneity in the meta-analysis? One way is through graphical assessment, which is very obvious to everybody. There are two forest plots here, one on the left, one on the right. You can open your mic if you want to answer. What differences do you see here? Anyone? Do you see any differences between the two forest plots?
Definitely. They are so obvious, I think.
Yeah.
The one on the left, on the right seems scattered around the midpoint.
Mm-hmm.
A lot of their means are outside so it shows obvious heterogeneity, but the one on the left, they are so close to the midpoint and tightly packed, even though they are few.
Yeah.
Yeah.
Yeah,
That's
that
my
is
observation.
I mean, that is perfectly what we are looking for here. So the point here is that just looking at the forest plot, you can already see whether the studies are heterogeneous or homogeneous. And the heterogeneity here reflects in the estimates of the studies. So as you can see here, they are scattered all over the place. Some of them are not overlapping. For instance, this and this, there is no overlap in their confidence interval. This and this are not overlapping. So they are scattered here and there. But this one are overlapping so much and are very close to each other. So just looking at it, we can see that there are the studies are heterogeneous or homogeneous to that extent. So poor overlap indicates presence of heterogeneity. I got a message here. Okay, let's go to the next.
Sorry, Bright, I have a question. Sorry.
Yes, please.
Like, can you say that the one on the right, that the confidence interval is wider based on that?
I mean the confidence interval for these studies.
Yeah, is it wider? Can you?
No, this is not dependent on the confidence interval. You can use any scale to make this, but if the studies are not overlapping, they're not overlapping, regardless of what scale you use to make the confidence. But I don't think the confidence intervals are wider because you can see this, that they are very close there.
The estimates are scattered.
Yeah.
Hello,
so,
sir.
Yes, please.
Hello, sir. So what's the conclusion? Because I had issues with network, so I didn't really get what you were saying the other.
Yeah, so what I was saying is that we want to detect heterogeneity in the meta-analysis we do. And one way we can do that is just to visually inspect the forest plots. And so I've given two forest plots in this slide here, one on the left, one on the right, just to say that
Right, yes.
this one, the studies, the estimates of the studies are close to each other because they overlap themselves.
Tightly packed.
Yes, so you can see that they overlap. But this one, they are not overlapping in many instances. For instance, this is not overlapping with this. So they are scattered here and there, So we can conclude that this meta-analysis here has more heterogeneous studies when you compare it to this meta-analysis here. Okay? All right. So another way of doing this, it's to perform a formal statistical test, a chi-square test, which tests whether the studies are heterogeneous. And when it does that, it gives a value, and that value indicates the amount of differences that exist between the studies that is due to real differences and not by chance.
Okay.
So differences that exist in the studies that are due to other factors rather than chance. So we perform that test and it gives us a p-value that is attached to the test value we get. So if you have low p-value, it indicates the presence of heterogeneity. So meaning that the observed differences are not due to chance alone. Okay. So this is the test made, and then it calculates what we call the I-square value. And once it calculates it, it expresses it as a percentage. And so the I-square gives a percentage. I see some. Please, can you mute your mic if you're not speaking? Okay, thank you. So the I-square value comes as a percentage, and it gives an indication of the percentage of the variability in the estimates across the studies that is due to heterogeneity rather than chance. So that is what the I-square. And from the papers you have reviewed this morning, you see that some of the studies have calculated the I-square value, and they have used the I-square value to decide whether to use fixed effects or random effects model. The I-square value is not for that purpose. Even before we combine the studies, we can have a very good impression of the differences. And then we perform the meta-analysis. And when we perform the meta-analysis, we can then estimate the amount of differences that may exist there. Okay, so we can estimate the amount of differences that may be there due to the differences we already had impression about, and that will be reflected in the I-square. In the field of meta-analysis and from the developments that have been made, people have developed some what they call I-square thresholds, which can give you an impression of what you should consider to be important difference or something you can ignore. But I have to say that this is only a guide. This is only a guide. Because there are problems with this test. It requires, I mean, it's sensitive to power, the number of studies you include there. If there are so many studies you include, the I-square value may be statistically significant, not that there are important differences between the studies, but because the analysis has power to detect even minimal differences that may not have any clinical relevance. So anyway, what happens is that we need to use this value as well as our knowledge of what we see from the studies. But this is a threshold they have recommended. And this threshold here, I will repeat it again, that this threshold is not used to decide whether to perform phase effect or random effect. This threshold here is an indication of what do I do next. If I have observed this level of heterogeneity reflected in the I-square, what is the next step? Do I ignore it and say, well, it doesn't matter? And that is the first threshold I've indicated here. Or if I observe substantial heterogeneity, what do I do? Do I investigate it to understand what may be explaining this heterogeneity? That is the essence of the I-square value. not to make a decision on which method to use, but a decision of the next step in the analysis. Okay, so now I have shown you how to detect and the I-square value. Yeah. Why do the threshold overlap? Because it's arbitrary. So I have put in here, some may say 0 to 20, some may say 0 to 30, some may say 0 to 40. And so they overlap because there is no consensus of where the starting value is and where the starting value ends. So this is an arbitrary threshold. And so don't put too much belief in it as a gold standard, but rather as a guide to evaluate your analysis. Many people trust so much on the I-square value that they overlook the other aspect that may be there, because the heterogeneity of the studies may really depend as well in factors that we have not collected in the studies, that have not been reported in the studies we have. So you need to use your common sense of the field and the result that manifests in front of you to make this judgment. But the I-square value is a guide for you to decide on what is the next step I take in evaluating my results. Okay, how do you address the heterogeneity? If you find that there is heterogeneity, check again that you have not made mistake in your data extraction. And that is why the systematic review is important in the way it is done, because it is done in a systematic way. Two people are doing it. So if there is any oversight in collecting the data, at least one person will detect that. And that is why I mentioned, if you see a systematic review that is done by a very enthusiastic author, one author, and he confidently send it to a journal and they publish it, then you know that that is actually rubbish, because it is impossible to do an objective work as one person in a systematic review. And so far, I think you can appreciate that. If the heterogeneity is so much, you can see also judging by your evaluation of the studies you see, you can decide not to derive pooled estimates. And this is one of the things I mentioned. The fancy things today, people want you to do a systematic review and do a meta-analysis, and they want you to force it. But you can see that we take time to make these decisions, to evaluate, is it reasonable to combine the studies or is it not? And so if you decide that there is so much heterogeneity, then one of the decisions may be, well, we are not interested in the pooled estimate because that will not be informative. Rather, what you can do, which I mentioned the first day, we defined meta-analysis. You see that you can use the meta-analysis now to investigate the heterogeneity, to find what could be given this heterogeneous results. This can be done through what we call the subgroup analysis, the meta-regression, sensitivity analysis. So once you decide that where the pooled estimate is not relevant here, this you can do to investigate. And so the goal of the systematic review, we then move, instead of deriving a pooled estimate, it will be trying to address or explain why the studies are heterogeneous. And that's, once you have done it, we give you an indication of recommendations to make in going forward, particularly with regards to the research area to improve how the things are done going forward. Sometimes the heterogeneity may also result from differences in the effect measures used. If there are some differences there, you can try to convert to other measures to see if it explains these differences between the estimates in the study. Okay, the time is flying. So that is heterogeneity, and you can see, and I think you understand what that means now. We'll investigate that in the afternoon when we do the meta-analysis, and we see how this reflects in reality. Another thing in systematic review and meta-analysis is what we call publication bias. Publication bias is a term that reflects lots of things, but it's a term that describes the tendency of publishing a paper due to the results or significance or whatever other factors. Sometimes it may be due to the language, it may be due to the sample size of the study, and these are realities we face in publication. If you have what we call statistical significant results, interesting results, journals are more likely to publish than studies that do not provide statistical significant result or interesting result. That is a reality, and that is what we have to live with. And if you have very large study, it is more likely to be published, and very large studies, of course, will be more likely to detect statistical significance than small studies. Large studies will be more likely to be published than small studies. It's clear. So I mentioned that language can be a problem if English studies are more likely to be published than, and English studies are more likely to be indexed in the databases we're searching than studies from other languages. Yeah. And when you also write a paper, people are more likely to cite the big studies, interesting studies, than other studies that are not as interesting as other studies on that topic. And so this becomes a problem, because eventually, if studies are not published, it means that they end up in the drawer of the researcher. And when we do a systematic review, we search databases, we do not get the global picture of all the studies done on that topic. And it's problematic because the conclusion we reach will be based on a subset of all the studies that have been done. And once we reach that conclusion, it means that our conclusion is biased. So publication bias is a problem in systematic review and meta-analysis. So how do you address publication bias? How do you address it? There has been improvement in publication as well these days. There are journals that are dedicated to publishing non-significant findings, because the goal is that whatever has been done, publish it and let's have it, because it contributes to the growth of knowledge. When we have all the evidence available, we can reach a better conclusion than having selection of the evidence based on the fact that studies included are more likely published. So in terms of journal publication, there is improvement, and there is also improvement in terms of sources we can get studies that do not, for instance, end up in publications. For instance, thesis, master thesis, bachelor thesis, doctoral thesis can end up being deposited in certain platforms that you don't find in the mainstream databases, which are called nowadays gray literature. So to address publication bias, one step is to perform a comprehensive search. Search wide. I have, some of you have said that your topic, you may decide to make it a systematic review. Yeah, please note that what we are doing here is that we are searching only PubMed. If you decide to make it into a systematic review to publish it, then you need to expand the search, include different databases, search grey literature, conference abstract databases, contact experts in the field. So to ensure that you are exhaustive in your search. And then I say avoid unnecessary limitations because that may also affect what you retrieve. And then within the meta-analysis that is done, there are methods that have been developed as well to try to account for this, try to explain it. These methods all have limits of what they can do, but these are attempts to try to explain. One of those, I wouldn't cover trim and fill methods, but what it does is that it models what number of studies that have been included, and it can do some modeling to estimate in probabilistic term how many studies that could have been missed in the systematic review, in the meta-analysis, and can adjust the estimate you have received based on that assumption. For instance, if you do a meta-analysis and you include 10 studies, the trim and fill method, if you perform it, it can give you an indication of the number of studies you would have missed. And if you had included those studies, it can adjust the estimates you got from these 10 studies to tell you the estimate could have been this. Of course, this is probabilistic estimates there. So every method has its own limits, but these are attempts to use statistical methods within the meta-analysis to try to deal with this. So let's look at the funnel plot. The funnel plot is quite interesting thing. Many people sometimes find it difficult to understand that, but it's a plot that you use to see if there is a possibility that you are missing some studies. So what it does is that from the studies you have included in your meta-analysis, it plots an indicator of the sample size on the vertical, and then the effect estimate on the horizontal. An indicator of the sample size on the vertical and the effect estimate on the horizontal. And when it does that, as I will show you in the next slide, when it does that, it means that the studies that are large will usually go up in the plot, and the studies that are small will usually scatter down. And the goal is this. This is the plot, the funnel plot. It's an inverted funnel. So on the vertical axis, you have the indicator of the sample size. This is standard error of the estimate. So the standard error of the estimate gives you an indication of the sample size of the study. If a study is large, the standard error will be small. So this moves from the large value to the small values. So the studies up here will usually be the large studies. The studies down will usually be the small study because the sample size is small, reflected in the standard error. And on the horizontal is the effect estimates the studies have estimated. So the goal is that if you have a symmetric funnel plot, it gives an indication that there may not be presence of bias or publication bias, meaning that you have confidently included the relevant studies on this topic that should have been there. But if the funnel plot is not symmetric, if it is asymmetric, as you can see here, so these studies have been removed if you get it this way, it means that there are studies that have not been included. So you're missing some studies. And so the goal will be, how do we get these studies? The trim and fill method I mentioned, it uses some modeling strategies to estimate this number of studies and tries to fill in this. And then once it does that, it will update the estimate. So this is indication of presence of publication bias because the funnel plot is asymmetric. And this one is also indication of bias, that the small studies, even though we have found these small studies are actually exaggerating the effect, showing that whatever we are investigating here so this indicates that the small studies are exaggerating the effect. This is the null here, but you can see the big studies are closer to the null than the small studies are closer. So the small studies are exaggerating the effect. And this is a problem because it is possible that these studies here, these small studies, may not have been of high quality. And so if you improve the quality of these studies, we expect that some of them may move to this side and will make the funnel plot symmetric. And another way is to perform a formal test of the presence or absence of bias in the publication bias in the meta-analysis. So there are some tests here that are used to test for the funnel plot asymmetry. The common one used is the EGA test. What it does here, it's a regression method. It calculates and derives a p-value that indicates that the funnel plot is asymmetric if the p-value is greater than the threshold of 0.05, then it means that there is no evidence of publication bias in your study. But the problem here is that this test requires large amount of study for it to be efficient. So if you have small number of studies, this test will not be efficient. And if I also go to the funnel plot, it is recommended that you should perform a test of the funnel plot only when you have more than 10 studies. If you have less than 10 studies, it's not efficient because you will not have the right information, the right results. Okay, that is the publication bias. At least you can understand the motivation for it, that we have a problem because not everything done in research is published, and so we miss some studies, and we find a way how we can deal with this situation. That is why these methods have been proposed. And we have also dealt with the issue of publication, heterogeneity in the meta-analysis. Any quick question before we go to break?
Yes, I have a question.
Yes, please.
That's with regards to the plot. Can we go back to the plot, please?
Yeah.
You were saying that when you don't have studies outside of the null, then it means that there's so much bias in it. Could we refer to these other studies as outliers? Because it seems that when it was on the left, it was looking as if it wasn't, there was a lot of bias in it. So how do we differentiate when this is happening? Do we call them outliers, or what exactly are they?
I mean, if you do your meta-analysis and you do the funnel plot, you may get something like this. And so what it indicates that you are missing some studies. It indicates that you are missing some studies here. And this may be, and you can see that this studies missing, you can see that most of them are the small studies, because the big studies are filling within the funnel. Most of them are the small studies. And this is an a way of thinking that the small studies naturally are less likely to be published than the big studies, as I mentioned before. So if you have your funnel plots, it gives you an indication that you're missing some studies because of issue of publication bias, and then you can integrate this information in interpreting your results to say, this is what we have found, but based on the funnel plot we have produced, it is likely that some studies were missed, even though we performed comprehensive search of the literature. So before you can make that conclusion, you need to ensure that you perform comprehensive search, because it is possible that you have not done comprehensive search and then you are missing. And if you have done comprehensive search, perhaps the plot will look like this.
So in essence, looking at this graph, the lower the standard error, the bigger we tend to kind of term the study to be.
Yeah, so the smaller the standard error, the larger the study.
Okay.
Yeah.
Okay. Well, that's what this graph is saying.
Yeah. So the big studies are the one on top because the standard errors are smaller. So because the standard error here indicates the size of the study, because if you have a big study, the standard error will be smaller. If you have a small study, the standard error will be bigger. There.
Okay, that's fine.
So this plot, yes, please.
Okay, I have a question. So does it mean that when you're doing a systemic analysis, systemic review, sorry, that the right plot to get is the symmetric funnel plot? Is that what you're trying to arrive at?
Well, that is what we aim for. That is what we aim for if we are able to have access to all that is published.
Okay.
But rarely do we do so, because many things, many research done are not published. Not because the researchers don't want to publish. Sometimes they don't want to publish because they didn't have interesting results. But sometimes because when they send it to the journals don't accept it for different reasons, because the sample size is small, or they are not finding what is the conventional knowledge, and so it ends up that these researchers are discouraged, don't publish that, what they have found. So you end up not finding all the studies that have been done on that topic. And if that happens, you plot your funnel plot, you have not retrieved all the studies, your funnel plot will likely be asymmetric.
Great, thank you.
Okay, let's come back 15 past and continue from there. Okay, let's continue. I will like to ask that I will take the next two sessions together. So we may skip the next 10 minutes break because time is running fast. So we'll go to the lunch break at once after the next two sessions. Okay, so we have dealt with heterogeneity, we have dealt with publication bias. Now we can take the issue of heterogeneity forward. We have investigated and we see that the studies may be different based on the I-squared test or based on the investigation we make and see that the studies have some differences. The next question we'll ask is to understand what may be causing the differences. That is the next question. And we need to investigate this to understand, because it will help to synthesize the evidence. It will help to give a clear picture of what is there. So one of the approaches is to do subgroup analysis. And in doing subgroup analysis, what we do is now to do the analysis at the level of subgroups of some of the characteristics in the study. So this could be if you have studies that have said there is still background noise there. So if, for instance, you have sex or gender as a factor, in which you have included studies based on women, studies based on men, and you have combined this together, you can investigate this because it is possible that combining both genders together may be causing the heterogeneity you find. So you can do subgroup analysis by dividing men and having studies published on men separately from that of women. You can do this by age groups. You can do this by, for instance, educational level or whatever characteristics you have there. In classical epidemiology, you call this effect modification, meaning that the overall effect you see may differ between the subgroups in the population, and statisticians may call this interaction or something like that. So two main goals of subgroup analysis. One is to investigate heterogeneity, which I've mentioned. And you may also be motivated that it is possible that the effect you are seeing may be confined to certain subgroups. This is quite important in the research we do, not only in this context of systematic or meta-analysis, even in other contexts. Because, you know, the resources we have is very inadequate or limited to deal with the problems we have. And so when you do research, you want to know, for instance, if you have an intervention, you want to know which subgroup of the population that this intervention is most applicable to. And if you understand that, we will not waste the resources of giving intervention to the subgroup of population that does not benefit from it. So it helps us to really use our resources in the most efficient way. And also for clinical decisions, if you know that a therapy is not helpful for certain patients, you don't give it to them because you just waste the therapy and there may be side effects that may occur. So subgroup analysis can help us to find out what subgroup of the population or what subgroup of certain characteristics will benefit more from the intervention or therapy and what subgroup may not benefit as much. Okay, so how do you do this? You split your study based at the level of the subgroup you are interested in, then you perform the analysis again to compute the effect estimate at that level of the subgroups. We'll see this in reality this afternoon, but this is the same process you do in your normal analysis. One thing is that you need a good number of papers in order to really see a clear picture of any differences between these subgroups. So if you have two studies, it doesn't make sense to just divide them into two. So the more studies you have, the better. And yeah, we also, that is why when you set out to do your study, you need to specify your hypothesis clearly so that it is not fishing expedition just to test things there. Yeah, people do that just to test this and that. If something just pops up there, they shout to the heavens, I found something. But this may not be a hypothesis they have set before or a goal they set beforehand. So that is why the protocol, as I mentioned at the first day, it's important to develop the protocol so that we know beforehand what we are investigating. So there are some caveats you have to note when you do subgroups. So it needs to be done cautiously and interpreted cautiously. Yeah, state it in the protocol. This is what you plan to do. And when you state in the protocol, you are motivated by underlying premise or evidence why you want to investigate that subgroup. So, yeah, so keep it to the minimum. Don't do too much subgroups, because the more you do, you know, what's it called? That's in every 20 tests you do, one of them will be statistically significant. Not because it is a reality, but that is what is there. So you do 20 tests and you find, oh, one is significant, then you are happy. Nope, that is what happens. So keep it to the minimum and don't do so much. That relates to multiple testing. Okay. Yeah. So the subgroup should be measured at the baseline. You evaluate direction of effect. Yeah, you should specify the hypothesis beforehand. You should consider the size of the subgroup. Is it meaningful? And then you evaluate whether the observed effect is similar across the subgroups. Okay. Another issue I would like to present here is meta-regression. Meta-regression. Meta-regression is part of the meta-analysis strategies. Unfortunately, REFMAN is not able to. REFMAN is limited quite a lot. I will come back to that in the afternoon to prescribe other software you can use. But we're using it here because it's free. Most people do not have access to some of, for instance, data. And if you go to R, not everybody knows how to do that. So then we are forced to use REFMAN. But the concept is important to understand so that if you eventually want to try to use other programs like Stata or R or comprehensive meta-analysis, SPSS has not been able to have a routine for doing meta-analysis. I've not come across that. Yeah, but we use REFMAN. It doesn't have that. But meta-regression gives the same premise as the regression analysis we do in our statistical analysis. When you want to do regression to adjust for factors, extraneous factors, confounding factors, and so on and so forth. So you use that, try to explain what could be explaining the heterogeneity. When you do the meta-regression, then it is now possible, instead of doing the subgroups by one subgroup at a time, when you do meta-regression, you are able to include several factors, and you adjust for all these factors to see how, together, how they affect the effect estimate. That is the goal. If I take all these factors into account, what would be the effect estimate? Does it change? Does it influence it? So that is what meta-regression does. So it's an extension of a subgroup analysis, but now many factors have been taken into account. Even though we are not using Stata here, I have put Stata data, and I've put the codes there. You can take that. If you're a Stata user, you can take that and run it. The meta-regression has also been, I have put the code for the meta-regression in the Stata code in the Dropbox. So you can run this and see. If you have any question before the end of the class, the course, you come back to me, we can look at it together. So that is what the meta-regression does. So taking all the factors together into account and perform a regression analysis within the meta-analysis. Yeah, so this is also influenced by the number of studies that are included, like when you do the subgroup, the number of studies. The more studies you have, the better estimate we can get. And this is not recommended when you have less than 10 studies. This less than 10 studies also applies to when you do publication bias. And by the way, the publication bias in RevMan can only be done when you do the fixed effect meta-analysis in RevMan. If you do the random effects, RevMan does not perform the funnel plots for random effects. It does for fixed effects. The reason I'm not sure, but there has been some theoretical debate whether it's useful for random effects to perform the funnel plot or not. But that is what RevMan has. Okay, another way to investigate the heterogeneity and the robustness of our findings is through what we call sensitivity analysis. And I know this is a term most people are familiar with, but if not, I will try to explain. This is different from subgroup analysis. Sometimes people have asked the question, what is the difference between subgroup and sensitivity analysis? The sensitivity analysis, what you do is that you investigate to see the extent of your results, how much it is affected if you make different assumptions to your results. So you have the result you have calculated from all the studies, and you may be asking the question, if I make some assumptions here, will the studies be different? I mean, will the results be different? So you test these assumptions within your study and evaluate. So for instance, the publication bias we do is a form of sensitivity analysis as well. But this is the way it works, that you want to, for instance, to say decisions I have made during the searches. For instance, the studies I have retrieved from different databases. If I remove, for instance, studies from PubMed and I analyze only studies from Embase, do I get the same result as I get when all the studies are together? For instance, also eligibility criteria, you may say, okay, if I perform my analysis and then because I've included studies from published in different languages, if I only analyze English language-based studies, do the result change from the overall result I got before? You could also do the sensitivity analysis based on the quality assessment results you have. You could also do this. You could do subgroup analysis by this. You could also do sensitivity analysis based on this. For instance, if you have a result, you may be asking, what if I analyze only the high quality studies? Would that change my results? Would the overall results and conclusion change? So you can do the sensitivity analysis using different parameters and making these decisions in the process. So the goal of sensitivity analysis is to identify decisions whose values are most likely to change the results of the meta-analysis. So the question the sensitivity analysis asks, are the findings robust to decisions made in the process of obtaining them? It involves that you repeat the meta-analysis, substituting it alternative decisions for decisions that were arbitrary or unclear. You can specify your sensitivity analysis beforehand, but you can also specify them during the analysis. This is not like the subgroup analysis. Subgroup analysis you should already specify in the protocol, but sensitivity analysis is a stage where you want to test the robustness of your findings. So you could come up with some scenarios you want to investigate once you have the results. Okay, so this is the way it works. You perform your meta-analysis with all the studies. We'll call this meta-analysis 1. Then you may decide, okay, let me exclude the low quality studies and then repeat the analysis again. And that is meta-analysis 2. You examine the results and you see meta-analysis 1 and 2. You compare them to see, is there any difference? And if there is no difference between two of them, then you are sure that this is acceptable. And so removing the low quality studies do not change the interpretation you get from them. But if after you remove the low quality studies and the results you obtain here differs from this, then it means that the low quality studies are affecting the results. And so if they are different, then you interpret with caution, because the goal is that we will synthesize all the evidence, but if the low quality studies are producing different results, then you need to interpret with caution. So I've said there, publication bias or cumulative meta-analysis. Cumulative meta-analysis is meta-analysis that you have done a meta-analysis and you add more studies as more studies are published on that topic. You keep adding them. And so once you add, it may change the estimate you had previously. Okay, so what is the difference between sensitivity analysis and subgroup analysis? I think this should be clear. The aim of the sensitivity analysis is not to estimate effect in subgroups. It's not to estimate effect in subgroups, to compare the subgroups. It is to make some exclusion and then compare the results you get in subgroup to the results you get in the overall. But in subgroup analysis, the goal is to compare results between subgroups. I hope this is clear enough for you. Okay, any question this far before we go to the next stage?
Yes, Bright, I've got a question, a general one.
Yeah, please.
I'm wondering how difficult it is to obtain the raw data from the articles. Or what's the success you have? You have 50% of success to get or to obtain the raw data for analysis?
It's not clear for me. You mean in terms of time or availability of the data you're looking for?
Availability of the data,
Okay.
yes.
Okay. Yeah. Well, in most cases, the data are there in the papers. In most cases, I have not quantified this in terms of percentages, but yeah, in most cases, the data are there. What may happen is that if the particular estimates you are looking for are not there, then you contact the authors to see if they can supply you that. Another way it may also happen is that the way the estimates have been calculated in the study is not the way you are looking for. So you may also contact the authors, or if it's possible for you to convert it to the way you are interested, then you can make that conversion. But in most cases, you'll find the data in the studies there.
Okay, thank you.
Yep.
Yeah, I want to ask a question.
Yes, Prof.
Yeah, there are two words that you mentioned during the presentation. We have effects, and the second one, power. Now, I know that effect, is it the same as effect size, which we use in intervention studies to identify the extent to which the intervention has produced changes, or is effect a different one?
Yeah, so when I use effect estimate here, what I mean is the effect of the intervention on the outcome. And this may
How do we
be,
measure it?
this may be, if for instance, if you have an intervention that is looking at, for instance, blood pressure, this may be in the form of mean and the standard deviation. If you're looking at effect that estimates an outcome that is binary, this may come in the form of odds ratio, risk ratio, hazard ratio. So it depends on the question the studies have done, but effect, I have used it in general term as the estimates that are produced indicating the effect of an intervention or an exposure on an outcome.
Okay.
Yeah.
So something, it's almost, because we use odds ratio and effect size, the Cohen effect size interchangeably sometimes.
Yeah, the
Now,
Cohen.
the second one.
Yeah, the Cohen, you can actually convert effect sizes to different effect sizes. So the Cohen is also effect size on its own. The prevalence is also effect size on its own, and so on and so forth. So they can come in different ways.
Okay. The second one used power. Is this power the same as deriving the sample size? Like we have the 95% confidence level for type 1 error,
yeah,
the power that we use for type 2 error. Is
Yeah,
it the same power?
That is what I mean.
Okay.
That is what I mean. So when I talk about power, I'm referring to reflection of the confidence interval, the standard error, the sample size of the study. Those constitute the power, and the power is the ability of sufficiency of that study to be able to detect what is set out to detect.
Good. And most times these days, most researchers don't compute power. Very few researchers, especially the high quality researchers, compute or consider power in their study designs.
Of course, you can understand that, Prof. You know that many things are not done the right way nowadays.
I know.
The motivation to publish or if you calculate power, you see that if you want to estimate a particular effect, you may need 1,000 people, and the more your sample size increases, the more resources you need to do that.
Yes.
So people try to avoid that, not to be trapped into, okay, if you calculated 1,000, why are you recruiting 200 people? So
it boils down to many studies will be excluded in systematic review. So if one wants to have their studies included in future systematic review, they should do it properly.
Yes, but if not done properly, the systematic review will not help you to be able to grade those studies. So you can say that this studies was of poor quality. And it was of poor quality because the sample, it was underpowered. So we need more power studies to answer this question. So that is one thing you can get from the systematic review, because it helps you to critique the studies and grade them where they belong. And we get information in this process for research in going forward that most of the studies we have are underpowered. So we are not able to make a conclusion on what is happening. So we need more powered studies. And you, in the systematic review, you can actually propose a power calculation and say, for a study to address this topic, you need this number of participants to do that.
Very good. Thank you very much.
Thank you. Yes, Posi,
No,
you were.
how do you bring in the power calculation? No. You said you can actually, in making a suggestion that a study is underpowered, you can actually do the power calculation.
Yeah, you can do that.
How do you do it?
Oh, it's beyond this course.
I know it's beyond. Yeah.
It's beyond this course, but of course, when you want to do that, statisticians can help you to do that, to calculate the power. So they will require a number of things from you, different assumptions you are making, what estimate you want to calculate. They will need all those to help you to calculate the power. So there are ways to calculate the power of a study and the sample size.
But you can use the same power estimation in systematic reviews.
No, that's not what I mean.
Some systematic reviews actually calculate the power of the review. Is it possible? Have I gotten it wrong?
Not within the systematic review, of course, because this is within the primary studies you conduct. That is when you make the power calculations.
Not on reviews.
No, not on reviews. But what I'm saying on the reviews is that if the problem of the studies that have been published is a problem of underpowered studies, few participants in the studies, in addition to the review you have made, and you make a quality statement of what the evidence is, you can propose a power calculation within your review. That could be something you can do. Okay. Yeah, Posi, you were raising your hand.
Yes. Still related to the question that Professor Astuma asked. Are these statistical results expected to be in literature that is meant to be reviewed, or do we have the liberty to request for raw data and do the calculations ourselves, or it has to be in the papers that we are reviewing?
Well, as I was explaining, once we do this, we usually collect the papers from the literature, and then you see if the estimates you're looking for are there in the studies. If they are not there, then you can contact the authors to ask them for the estimate.
Okay, thank you.
Yeah, so anything you don't have in the papers, you are at liberty to contact the authors to ask. Sometimes you succeed, sometimes you don't succeed.
So for every unsuccessful search for these statistical results, the paper gets discarded?
Not discarded, you don't get it discarded. So you have to integrate it in interpretation. You have to indicate. Sometimes what we have done is that if we have conference abstracts that have been published, and then we have contacted the authors and we don't get full data, we make a table of conference abstract or ongoing studies to say that we contacted the authors. Sometimes we indicate we contacted the authors on this date. We had 3 reminders, and without any response, we are reporting it here. This is what this study has found. But because it is a conference abstract, we could not appraise the quality of the study. So because of that, we have not included it in our meta-analysis. We'll wait to see if this study will be published in the future, so that the point I'm going to make here is when we are updating the systematic review, we can integrate the full paper into our analysis. Yeah, David, were you trying to say something?
Oh, yeah. Just a quick comment. I was saying that discussions about the quality also kind of emphasize that not only in systematic review, but also when we are conducting our individual studies, we should look at the issue of power and the quality.
Mm-hmm.
No one wants to see his study included in the systematic review and rated poor quality. So this is something that we have to bear in mind.
Yeah, of course. So you can see the essence of systematic review. If you get away publishing your study, even if it's poor quality, systematic review will find you out and tell you that you have not done a good job. Okay, let me finish this session, and so I have mentioned now that we have done our job, and as you can see, we are almost there, because if we are reporting it, if you're writing it, it means that we have done everything. We have finished everything, and you can see that the process is getting to reporting needs care. You need to invest effort in doing this before you can report. But once, let's assume that we have finished our systematic review. Once you're reporting it, I've mentioned that we have guidelines. The PRISMA guideline is the gold standard for reporting your systematic review. Most journals, as they do for other study designs, if you submit, they will ask you to complete the PRISMA checklist. This has a checklist. It has a PRISMA statement and guidelines of things you need to take into account, and it gives example how you can report different sections of your systematic review. And then it has this 27 checklist of items that are required. And so you have this checklist where you, when you submit your paper to the journal wants you to indicate on what page have you described this requirement. On what page have you described this requirement? There are 27 of those, and you need to fill that in. So this is helpful. If you want to write your systematic review, take the PRISMA guideline and see what they have recommended. It's quite nice. Well, once you have done that, you have written, then you write and publish. I'm not going into detail about publishing. Another course may be coming up in the future about this, but it's the same process it takes you when you do your normal papers. You submit, and then you cross your fingers, you wait for review questions and comments you can deal with. Okay, updating. The systematic review sometimes can be updated. It's not frequent. The Cochrane reviews most of the times are updated. And the Cochrane review recommends that you update around 2 years or so. But what happens is that in some fields, the evidence is rapid. In some fields, the evidence accumulates quite gradually. But it is good to update. And what you do when you update is that you bring the previous published systematic review up to date. So you identify new evidence that have come, and you include that in the previous evidence to see what is the current state of the art. This can also take some time. So I have some considerations for updating. Yeah, I mentioned the rapidity of the review of the topic. It is good to update because if we don't update and several studies have been published, we may be making decisions based on old evidence, which perhaps from the new studies published may affect or change what we already know. So it's very important to update where there is need for that. When do you update? Yeah, I mentioned Cochrane 2 years, no consensus on when. Don't update too soon. You could introduce bias because if the studies you have published or reviewed previously are small studies, and just a sudden a big study is published, that big study will overwhelm the previous studies, of course. So And it's possible that the big study, if another big study is done, may be different from that study. So don't be too quick to do it. Just allow the evidence to accumulate a little bit, but don't delay it so long. And this depends on the field of research. There's no general consensus on this. Okay, how do you update? You have the previous database you have searched, this previous paper you have published. What you do now is that you search the databases again, but this will include from the time after your previous search ended. So you search, if for instance, you have searched for studies in the previous thematic review, studies from 1960 until 2018. And in 2020, you want to update thematic reviews. So what you do that you search studies from 2019 or 18, because sometimes the indexing of the papers takes some time before they appear. So you can include that year the previous one ended, just in case some studies that were supposed to appear in 2019 were indexed in 2018. So I can capture those. So once you have done that, you screen the way we do things, then you combine your data to the previous one and synthesize it. And if you're doing meta-analysis, you combine the new studies to the previous ones and do the synthesis. Okay, that was quick. Any question?
Yes, please. I have a question.
Yeah.
Also seen review of reviews, and I wanted to ask about how important it is with respect to some of these statistical biases it may have in the individual reviews that are about to be combined into another review to have a review.
I didn't get that, Josephine. Can you come back?
I am saying that I've also come across review of reviews.
Mm-hmm.
It's reviewing other systematic literature reviews.
Yeah.
So in the face of this, how is it a good step to take, especially when you know that these individual systematic reviews that you are bringing on board also have their own inherent statistical, like heterogeneity issues and all those kind of things? Is it good to bring all these together to also have an additional review of reviews again?
Yeah, we'll come back to that tomorrow, Josephine. This is a good question. We mentioned the first day what we call the umbrella reviews. So that will take us into that. So let's keep it for tomorrow. We are going to talk about umbrella reviews tomorrow. Okay?
Okay, thank you.
Any other question? Was this so easy or you're overwhelmed? I'm not hearing any.
I don't know if I should ask a question. I thank you very much. This part looks softer. It looks softer. the hard to chew parts are the data extraction exports and then the meta-analysis. So before I know we're going to wrap up by God's grace on Friday. So I think whilst you're waiting for more questions, it's also important for you to also ask for areas where people are having difficulties. It's a large class of about 40 persons. Some people are very smart to understand it much better. Some people are still slow, trying to grapple with, instead of, okay, we're at the stage of reporting, but you got to write something before you can report this stuff. So once in a while, as you go through the various units, sub-units, you go through the areas that are appearing a little bit difficult. Data extraction, screening, export. Ryan and the rest. So as we work towards the end, these are the areas I think you need to do more work to assist us. Thank you.
Yeah, well, it will be good when I go through the groups, because as you see, we have so many people here, so I wouldn't know what people are struggling with, but I think we can deal with that in the groups as I pass through the groups. Yesterday, I was in some groups that some of these issues were resolved. So we can do that, or if you have challenges, you can also write me personally, because then we can deal with that. Otherwise, we can meet the different specific needs of everyone. And that is why I try each day to go back to what happened the previous day. And we don't have so much time, of course, even though we're using full time for the week, but you can see that there are many things that could have been covered in more detail, but there's not much time about that. But you can always come back to me and let me see what I can do to that.
Okay.
Yeah. Godfrey,
Yeah. Yes, I have a question. I know we are concentrating on the hard data. So when will we have some reflection on the soft, the qualitative, which is my hard interest?
Qualitative,
because all this we are talking about, research, this, that, all this is the quantitative, which is good. Any reflections on the qualitative, how it can complement and how it can merge with all this SR and MR to make sense of what we have?
No, for this course, I mentioned it. That was one of the things I mentioned the first day. If you check the slide, I said that things we will not be able to cover here. There were two of them. The qualitative systematic review and the Bayesian meta-analysis. I'm not a qualitative researcher. Of course, I appreciate qualitative research. It adds to our evidence, but it's beyond the scope of this course to deal with the qualitative systematic review.
Yeah, thank you. But just reflections in terms of this can be applicable, this can be useful, this can be that. That would be useful for me.
Well, the same process you go in terms of designing your question, in terms of making the searches. But once it comes to synthesis, you know, the qualitative research has a way it is with its own analysis, and that is an area I'm not conversant with. So I can't make any recommendation on how you go about this. But there are this is a field that is now growing quite wide. So you can read about it. I think there are resources you can use to really, you can use to complement what this course has offered you.
Okay, thank you. Appreciate it.
Okay, let's come back. My time, 1 o'clock, so that we can take it from there. And please ensure that you have your RevMan ready so that we can put this into practice. So let's go for the lunch break.
Thank you. Ebra. Do rabo. Understand?
Okay. Welcome back, everyone. So now we will walk through the meta-analysis this afternoon. I think we are doing this until 3:50 or so. But let's see how far we get, then you can continue in your breakout rooms with your project. So I assume that everyone has installed the RevMan. Okay, I'm going to demonstrate how you can perform your meta-analysis using RevMan. And we'll be working on data sets that is looking at physical activity and prostate cancer mortality. The data set we'll be using here is fictitious and it's not real data set. So whatever we'll find here doesn't have any meaning. It's only used to demonstrate how you can perform your own meta-analysis. So please just bear that in mind. Okay. There are several software that could be used. Unfortunately, not all of them. Yeah, I didn't put SAS there. SAS, you can also do meta-analysis with SAS. Until now, I'm not aware of meta-analysis being able to be done using SPSS. The RevMan and the comprehensive meta-analysis have interfaces that are adaptable to Excel, meaning that they are kind of spreadsheet-based programs. So they become more handy to handle for most people who are used to Excel and they can use this too. The comprehensive meta-analysis, you have to pay to get it. It has a trial version that lasts for, I think, 10 days or so. It has limitations, but you can try that. R is one that is very flexible, but it requires programming skills to do it. And of course, Theta has the same. You need to write some codes. But Theta, you can also use the click menu option as well. So, but if you come to RevMan,
no one catch you say emergency.
Off your mute your mics.
Okay. So RevMan is free. It's freely available, and so you can easily get it. And I think it serves to a great extent the purpose of what you'll be doing. But it has some limitations. limited in terms of evaluating publication bias, and you can't do meta regression with it. With data, you can do most things. With R, you can do most things as well. So just to bear in mind that what we'll do here is to introduce you to the situations, and then you can take this forward to see how you can improve what you do. Any question on this? Any question? Okay, none. So we will continue. What is next? Nope, I'll come back to this. Okay, I will stop showing this. I will go to my RevMan. Please open your RevMan as I do mine here. And I hope you have also downloaded the different data I have in the Dropbox. So my RevMan is loading here. Do you see that? You see my screen?
Yes.
I hope you get the same thing.
Yes. Yes, sure.
Yes, Prof.
Link to download RevMan. I sent the link.
You sent it in the first folder.
Hmm?
In the first email, you sent it.
Yeah, I can send you the link here. Okay, so please you try as much as possible to follow. I will go as slow as possible. So if you have this, what we should do what is okay? Okay. I want to say that RevMan is the software the Cochrane Group uses to perform Cochrane systematic reviews. And so it's not just a software that is used for doing meta-analysis. It is the software Cochrane uses to do the systematic review from beginning to the end. And you see that. But what happens is that we are not doing Cochrane review. We're not doing Cochrane review, and so the things that we would do within the Cochrane review process, we're not doing them here in the sense that we're not using RevMan to start the review from the beginning. If you're doing Cochrane review, you must stick with Refman. I've not used it to do my systematic reviews previously. So, but you can just use it to perform your meta-analysis. Okay, that is why when you download it, asking you whether you are using it to perform Cochrane review or is it for academic purposes or something like that. Okay, so let me now, if we have this window as I have, you can take this. You see what I took? Did you see what I did? The previous window that came up, take create new review, something like that. I think that is what is written there. My video is off.
Guys, would you want to go through this? You say you pick what? Create new review?
Yeah, something like that.
Okay, okay. From the
Yeah.
file.
Yeah, you can. No, there was a pop-up window that came. So you select the create new or something like that. I think that was on the left side. If you click it,
Please, please, how we didn't get that. Can you please go over that again?
Did you get the pop-up window that comes up there when you open Refman?
Yes, sir.
So on the left side, you have options on that pop-up window. Select the one that indicates something like create new review.
I do not have that option here. I have go to my review, open a review from a file, use a tutorial, view help, read the handbook.
Can you say that again? The first one is?
Go to my reviews.
The second one?
Open a review from a file.
The third one?
Use the tutorial.
Okay. Anyway, close that. If you don't get that, what I was asking, close that pop-up window, and then you go to the file on the top menu here. You see this? Are you seeing my cursor?
Yes.
Yeah. So take new here. Okay. So what we ask us to do here is that we click finish. Usually this is what I do. I click finish. And when you click finish, you see this window changes and comes up this.
Yes.
Okay. So
Yes.
on the left side, yeah, it's recording. Yeah, it's recording. The session is recording. I remembered now to click it. Okay. So on the left side, as I said, the Refman is used to conduct Cochrane reviews. And there they start from the beginning, protocol, title of the review, the main text, and all this. Usually when you conduct the Cochrane, you use this. But we are not using this for Cochrane review. So what we want to do is to do the meta-analysis using this program. And so what we will do is we have done the data extraction and we have harmonized our data in a way that we have calculated our effect estimates. We have ensured that we have common estimates and we are ready to do the meta-analysis. And so what we do is to take the estimate and the studies to Refman. I will I will stop showing the RefMan and I will show you this. You have this file. Do you see the Excel file I have here? You have this file in your folder in the Dropbox. This file is there. In this Excel file, I have included the studies, and this I call study ID. The name of the study and the year it was conducted. Of course, I have put the year here again. The reason I have put it here for RefMan, putting the name of the study or the name of the author and the year the study was conducted together here is fine. But for Stata, I have done this so that I can have the year separate as a separate variable. So study ID is a variable, and the studies are like the different individuals in the data. And so if you see PA, it means physical activity. So this is the cases of physical activity in the physical activity group. So this is the cases of prostate cancer in the physical activity group. The number of non-cases of prostate cancer deaths in the physical activity group, and the total number of persons in the study. So if you add these two, it should give you this. So the study has this total number of people, and amongst those who did physical activity, you have the number of prostate cancer deaths that are there. Among those who did not do physical activity, among those who did physical activity, the total number of survivors. And this goes for non-physical activity group here, the number of cases in this group, the number of non-cases, and the total. And here I have odds ratio. It could also be risk ratio. This could be changed to risk ratio. You have the lower confidence interval of the odds ratio, the upper confidence interval of the odds ratio. And then you have the log odds ratio. And you have the log lower confidence interval of the odds ratio and the log upper confidence interval of the odds ratio, and then the standard error of the odds ratio. This estimates the odds ratio, the lower confidence interval of the odds ratio, and the upper confidence interval of the odds ratio will usually come from the studies. And if the studies don't have that, you can see whether you can calculate from the study. Sometimes it's difficult, especially when you are doing observational studies whereby you need the adjusted estimates. But in randomized control trial, in most cases, you don't adjust for anything. And so the numbers here become sufficient. So if the study does not provide the risk estimate in randomized control trial, you can use the numbers here to estimate this. We'll go through, I will show you how this works in reality. But here you can see there is another variable and some other variables for these studies. The first one is study design. So for each study here, the study design is given. This study is a case.
Excuse me, sir.
Yes, please.
Sorry, sir. Sorry to take you back, sir.
Go
Sir,
ahead.
after you clicked finished. How did you get to this Excel interface, sir?
No,
I got logged out.
No, this is not from. I stopped sharing the RevMan. I opened Excel from my computer. So this is not part.
Okay, sir.
This is not part of the
RevMan.
RevMan. This Excel file, you have it in the Dropbox folder where I have included the meta-analysis files. So if you have downloaded that, you can open it and you see the same thing I am doing here. You see the same Excel file.
Okay, sir.
Yeah.
Okay,
So
sir. Thank you, sir.
this is study design, and each study is given its study design. Okay. Okay.
And Prof, please, I have a question.
Yes, please.
Yes, you mentioned that the OR you usually get it from the study. What's of the log odds ratio and then the form log CIN, log U, CI?
Yeah, those you may not have them in the papers most often. So that is why yesterday when I was describing data extraction, once you come to the point of doing the meta-analysis, you have to also do manipulation of the data to calculate new things you require. So this log, OR, log lower confidence interval, and log upper confidence interval, you can calculate it yourself. You can use your Excel to do that. So you just write the formula here, and that is what I have done. So I have just give me the natural log of I2, and this goes for all this here. So once I do that, I will calculate this, and then I will calculate the same for this. I will calculate the same for this. These log values are required to calculate the standard error, and the standard error is this formula: the log upper confidence interval minus the log lower confidence interval divided by 2 and divided by the z estimate 1.96. Usually when you're estimating the 95% confidence interval. So this is how you calculate it. So the point here is that to get this estimate, especially when you're doing observational studies, you can't use the numbers. To get this estimate, you need to manipulate the data in this way. Is that clear? Okay.
More or less. Yes. Sorry, Bright.
Yes, please.
For the original of the right, you get them from the articles, or you
I was off my data, so.
Sorry, Miguel, let me see.
I was asking for the original or the right use in column G and Q.
Yeah, just wait, Miguel. I said.
Okay.
Job, can you mute? Can you mute Job so that we can get what? Because I can't meet you here. Yeah, now go on, Miguel.
Okay, I was asking, in what concerns the column G and E high and G, the odds ratio, you calculate it from the data, or you get them from the papers?
Yeah. So this I here is based. I have calculated this. I told you that this data here is not real. So if I calculate, if I use these numbers, I will get this. I will get these numbers here. But usually you get this, and this from the papers. From the papers you are including.
Okay.
Usually you get that. But sometimes they may not be available, or they are available in a different way. And in that case, you can manipulate and calculate it in the way you want this to be. And sometimes you may need to go back to the authors to ask them to calculate for you, because the numbers they have in their studies are not sufficient for you to make that calculation. The data I have here is fictitious, and this, as you see, are observational studies. They are not clinical trials or randomized clinical trials. So that is why whatever I do here doesn't have any meaning, because usually we want this to be adjusted. And when it's adjusted, I can't get it directly from just using these numbers, because the adjusted numbers will be different. But I've done this assuming that, okay, I have done what I need to do and I've adjusted it and so on and so forth. So I go back to explaining that here you have the study design that describes what study design each study is. You have characteristics again that is called smoking, indicate that this study is a non-smoking study, so it included non-smokers as well as these studies, but these studies included only smokers, and so on and so forth. And there is another variable here called publication decade, meaning the decade the studies were published. And this may be an important factor if you consider that the evidence might change from decade to decade, or after some decades, we know better what is happening. And so here there is a stratification of the studies to those published before year 2000 and the studies published from year 2000 and onward. Here indicates the country where the study is published, and you can see the different countries there. And here is the region of the world, and here is they have put grouped them into two: non-European studies and European studies. And here we talked about the quality assessment. So the overall quality of each study is given here. Overall quality of each study is given here. And here is the total sample size of each study. And the sample size has also been dichotomized. The studies less than 200 participants and studies 200 and above participants are here. So this is the way this can appear. If you have several of these characteristics in your study you are interested in, this is the way you can organize your data. So I have done this in Excel, and I do this before I will take it to RefMan. Down here, I've made this. Why I've made this is that these ones you see here are based on the formulas I have used to calculate some of them. So what I have done is to put it here so that when I copy this to RefMan, I'm not copying the formulas. So that's why I have this here. Okay, any question up to this point?
Yes, I have a question.
Yes, please.
So in the RefMan, you copy from odd ratio to the standard error of odd ratio.
Yeah, we'll go back to RefMan, but if there's any question on this Excel, then if not, we'll go back to the RefMan. What I wanted to do here is to show you how you can get your data already in Excel. And once you have it in Excel like this, you can then, if you're using Stata, you can export this Excel to Stata. If you're using R, you can export this to R, or SAS, or comprehensive meta-analysis, you can copy and paste there. But in RevMan, I will show you how you can now take this information down there.
Okay, thanks.
Mhm. Okay, any other question? If not, we go back to RevMan then. So please join me to go back to RevMan. And I have shown you that when you're doing Cochrane systematic review, these are important. But for us who are only doing the meta-analysis, these are not important. So you can see these items here. There is one called studies and references. Studies and references.
Sorry, Bright, which file did you open in the RevMan?
I've not opened any file in the RevMan. All I have is just to open my RevMan. Just open your RevMan normally. Don't open any of those files I sent to you. Okay?
Thank you. Thank you. Okay.
When it's time to open those files, I will tell you. If you just open your RevMan, we are dealing with empty, nothing we have put in RevMan now.
I'm sorry, sir. I have a question.
Yes, please.
The interface you're having is not the same with mine. Could it be because I didn't choose the Cochrane ref?
I don't know what you have. What do you have there?
I think it's same here also.
Yeah.
What do you have here?
The interface you have is well detailed. It's looking like the Cochrane interface. What we have is the person. We clicked on the personal use. That's a non-Cochrane ref.
I'm not using the Cochrane. The same I have here.
Oh, really? Okay.
Yeah.
Mine is.
Did you use academic purpose?
Yes, I think that's what I chose. Yes.
Yeah, that is something I have here.
Is it also because of the version? Because I can see your version is 5.3, mine is 5.4.
Yeah, so you are even more advanced than me. So perhaps that can explain it.
Okay, that's fine.
Yeah, but I've clicked on the studies and references. Yeah.
Okay, so let's click
the
here.
options to pick, is it for academic use or commercial use?
Yeah, it should be academic use.
All right.
If you pick commercial, then I think you have to pay or something like that.
Okay.
And so if you take academic use, it will require your affiliation and things like that. Okay, I guess everybody is there now. And so if you click this button here, you guys toggle button, goes down and comes up depending on if you click it. If it's like this, you click it, goes down. So you can see how this works. I guess everybody is there. If you click references to studies, if you click this button here, you see this opens up. Included studies, excluded studies, studies awaiting classification, ongoing studies. So when you do the Cochrane, once you start extracting your data, putting this will be populating on their own. But we are interested, amongst all these, we're interested in one, and that is included studies. Is there anyone who is not up to this point? Okay, so we are good. So once you,
I'm sorry.
Excuse me, I think
I'm sorry.
The 5.4, has different
Interface.
Categories. When you click on the studies and references.
Yeah, what does
I
it
don't
have?
think so, because I have a 5.4 here and I have the same interface as Dr. Bright.
I also have 5.4. The interface is similar.
Yeah, so it's I'm free now.
So what could be wrong with the one we have?
I don't know.
Maybe you have to scroll up. Try
Are you
scrolling a little bit
the
up.
right button?
No,
I
up.
have 5.4.
I think for me, I
Try
experience
scrolling up. It's the same.
when you click on studies and references to studies come. You have to click on that one as well.
Yeah. Yeah. If I close this, if I click here, it's closed.
Yes, Josephine, thanks. It works. Now I have the same interface.
Great. Okay, so if I click here, it opens. If I click here, it opens. So Emmanuel, you can check if you find what is wrong there. Okay, so everyone is here now. What you do is right click. Yeah, Urban.
Right click on other references.
Yeah. Well,
I didn't get you. Your line is really bad.
I don't know if this is an important point, but in the main window, yes. Oh, I've been suffering network problems here since.
Yeah, I'm hearing you now.
But can you hear me now?
Yeah. I can hear you. Looks like there's a delay.
Okay, it's all right. Let's just move on. Let me not cause a delay. Move on.
Okay, yeah.
Okay, in the main window, I can see that like under the additional, under the additional references on the main window, the central window, under additional references, I can see the little box of add references, but I don't have it in mind.
What do you mean?
Hello?
Yeah, you shouldn't go here. Just restrict yourself to this place. Urban, leave out this. Just focus here. This is what we need here. Okay, so let's restrict ourselves here. You don't need this place. So now if you click here, if you highlight this as it is, you right click. Okay, right click. And then you click this one, add study. Okay. So what I will do here now, I will demonstrate with a few studies. If I go to my Excel, I copy the study ID of the first study, AHS 1998. You can do the same.
Sorry, so I didn't get to this part. I right-clicked and I'm having a different interface.
Okay, I close this. Are you here?
Yes, I am.
So can you right click like this? Right click, not left click.
Okay, I got it. Thank you.
Then you have add study. And so
Yes,
I
thank
copy the first one. While I have done this in Excel, I told you that I included the name of the study. It could be the author as well, or whatever description is used for the study, and a space and the year. If I do this, you can see here, RevMan is giving an example. If you do this, you can see what happens. So if you're here, click next.
Sorry,
Here,
sorry. Do we go to the Excel to copy?
yeah, or you can write what I have you see on my screen.
Yeah. Okay.
But I went to my Excel and copied this, and then you take next. You come here, it's giving you some description, data source. We have here published data only, unpublished data not sought. You can have other options depending on what you are including there. And mind you, this is a Cochrane-based software. So they have different options and sources they get the data. So we're happy with this and we click next. So when you click next, RevMan, because of the name of the author and the space you have given, RevMan already detected that the year of that study, the year that study was published is 1998. We're happy with that and we click next. Does the study have other identifiers you wish to add? Nope. We are happy with what we gave there. So we click next. So it has come to the end. You can see here it says wizard completed. And it said, what do you want to do after the wizard is closed? So now we have added one study. You have the options, nothing, add a reference for the new study, add another study in the same section. We have other studies to add. So we take this, and once you click this, you can see this was finished before. It changes to continue. We continue. And I will go to my Excel and I will copy the second study. And I will put it here. Always be careful that you don't give space in the name of the study. Only give space between the name and the year. And so we'll go through the same process here. Now I am faster because we have gone through it first. So I will continue. I will go to Excel again. I will copy the next study, and I will come to RevMan. I put it. So I will continue to do this until I finish bringing all the studies there.
Please, a quick question.
Yes, please.
Is the identifier, what is that one? What does it mean that something is an identifier?
I mean, some studies can have other descriptions you want to give to it. You understand?
Okay.
For instance, these studies we have here, some of them have real authors' names. Some of them have just the names of the study. So if perhaps you have the author's name and a description of the study, you could put the author's name here. And if you go to the next box, you could put the name of the study there. Okay.
Okay, thank you very much.
Was there a question? Yeah, somebody is helping me out here. Trial registration numbers, for example. Yeah, that's right. Rosalie, you have a question?
Hi, Bright. Is there any way to select the papers we want at once?
You mean
Or
all of them?
yes.
To be frank with you, this is the way I know.
Okay.
For Everman, for me, it's also boring. I don't use it. I use it in situations when I teach this course and I'm not using Stata. I use Stata only. So I've not figured that out.
Okay. I'm just wondering if we work with a huge number
Yeah,
of.
if you have 150 studies, so you have to spend the whole day doing this. Yeah, it's boring. But perhaps there is a way which I have not been able to figure out.
Okay. Thank you very much.
Yeah, I have a problem. I don't know what happened.
Yeah.
I closed. I cannot get that interface where we are putting the.
You close
those,
the Everman.
Yeah, because I click on included studies. I see at least down there, but I cannot.
Yeah, if you go here, once you highlight this, right click. Right click, not left click.
Okay.
Have you done that?
On the included, yes.
Yeah, right click, then you see add study.
Yes.
And this window will come up.
Okay.
And it is here you add the names and the years of the studies one by one.
Okay. It's clear.
Okay. So you continue to do this. You can see that this is boring and it requires some patience. I think if I was doing it alone, I will do all of them like this within 3 or 4 minutes. So the 20 studies would have been finished. Shouldn't take too much time. So if you're faster than me and you finish all the studies, you can just wait at the last part. And I will.
Bright,
Yes, please.
the last one doesn't have year. Should we add it?
The what?
The last one doesn't have a year. So should we add it?
The last one?
Plus, yes, close to the name. There is no year there,
What is
but I
the
see that it's 2005.
What is the name of the study?
Weinstein.
Weinstein has a year in my own. It doesn't have in your own.
No, I'll put the year.
Yeah.
It's 2005, but it's not close to the author.
Oh, is it?
Mhm.
Yeah, I'm not sure what happened. Yeah, please include it.
Should I add it? Okay.
Yeah. Mhm. Yeah, Urban, you have.
Yes, please. I got to the end and then I made a mistake and I want you to please correct me. I got to the end and somehow study, it was automatic since Reflex they have been adding studies and I didn't know what to do. Then I now cancel, so that command will be cancelled, but the whole window went off. What do I do?
Yeah,
you have to start all over again?
Yeah, I know this is exciting times. Yeah. I don't know what state you are. Perhaps it's if the whole RevMan closed, then it means that you need to start from the beginning. If
No, the whole RevMan didn't close. It was just the small window, the small window that closed. So, is there anywhere through the menu I can find what I have been doing?
Yeah, just a minute. So this is the last one. You went this way. You went this way.
I went to finish.
Okay, you went to
add
finish.
another study.
You went to finish.
No, I went to add another study. I didn't say nothing.
So once we finish the last one, now we click finish here. And you went to add another study.
Yes, that's what I should have done.
Yeah, but you went to add another study.
Exactly, that's the error I made.
Yeah, and it took you to add another study. What did you do? You closed. Urban, are you there?
I clicked add another study, and of course, the icon changed to continue, and I continued. And I now discovered on Excel that I had actually finished.
Then you close that window. Is that what you did?
That's what I did. Then it's
Is that what you did? Did you close the window?
Okay. Yes.
Okay.
No,
there's no problem. So what you do is.
Yeah, it happened like this exactly. So
Urban
what do I? Where will I find it?
Urban and everyone, if you have finished adding those, just click this one, expand it, so you will see those studies here. Here, included studies, expand this here, then you will see the studies here.
That's giving good information.
Do you see that, Urban? Urban, do you see what I am seeing here?
Okay.
Urban?
Yes, I have seen it.
Okay, great.
Exactly. Yes, I have. I'm seeing it now. Thank you.
Great. Okay.
So I didn't need to repeat it. Showed me where to. Exactly.
Any question this far? Okay, so what you can see here all is that we have now included the study names and years. That is what we have done here. We have not added any other thing. And that is what we would like to do now. Is there anyone that has not done up to this point? Anyone who is having
Sorry,
challenge?
I'm not. I'm lost. The only one that I was able to do. I didn't get it very well. My internet.
I also haven't. So, but
I have
been
not
following.
I just added. They said you take it back.
I've been following, but I haven't done any either.
Yes. So you can you give us like around 3 minutes?
Mine just got downloaded.
Oh, yes, just got downloaded.
Yes.
I've not been able to. I just finished downloading too, and I'm at under studies. I don't know how you got this pull down menu.
Well, since you're just downloading, you wouldn't know.
I'm under table studies and references. So you said I should right click on that. Then I right clicked, I saw notes, print, help, and handbook.
No, if you see this, studies and references, expand it.
How do
When
you
you expand it, you will have references like this. I will
you
collapse this.
You right click or left click to expand
So no, you just click your normal mouse, left click, expand this. If you expand this, you have this too. Studies and references, expand it here, you have these two.
Okay.
Then expand this, you have these items.
Okay. Okay.
To add the studies, you click this one, then right click.
Okay.
To add those studies you have added, then you click this one.
Okay.
And from there, you add the studies one by one, as we have done. But now we have finished adding, and if we have finished adding, if we expand these included studies, we will see those studies we have added here. Okay?
Okay, I've got it there. Now, how to add the studies in my calendar?
Yeah, you just go to the
So,
Excel.
sir,
Yes, please.
once I'm done adding, should I select nothing and finish or what?
Just if you're finished, just click finish.
Okay, but the cursor is going to be on nothing. I
Hmm?
mean, the selector is on nothing for the last page.
Yeah, just leave it on nothing and click finish.
All right, thank you, sir.
So if you do that, you come and expand this. Then you will see the studies you have added here. Do you see that?
Yes, I do.
Okay, great.
Thank you.
Is there anybody who is having troubles apart from those who have not started?
Those who have not started. Those who are finding it difficult to download the app.
I'm still adding. I've not finished. I think.
Okay. What happens is that the time is not on our side.
Yeah.
And so we need to proceed. The good thing is that this is recorded.
Yeah.
So you have the time to look over it again. And apart from this record, if you want to look more how you can use RefMan, there are many videos. YouTube, you can check through to fine tune what you are getting from here. This is only introduction. I guess that if you are using this by next year or so, you'll be the one guiding me through this, because I don't use this RefMan. I use other things to do my distance. So, but if you want to get through this, you can check the videos, or you go through this session we have gone through later on.
But you said you will send video.
Yeah, no, I didn't say I won't send video. I said I can't put it on the Dropbox because the videos are heavy, but I will find a way to send it to you.
Thank you.
Yeah, so, but otherwise, there are many videos on the internet about RefMan. Okay, so we can go on. If you see this, studies here, if you move your cursor across, you see that it says empty, meaning that these studies do not have anything yet. Yeah, I can't help you with this. Some people are having connection problems, so that is the limits of this online teaching course. But I was saying that if you move this, somehow it shows you that the studies are empty. Okay, so we want to find a way. I stop sharing Raveman and share. Where is my Excel? We want to. All we have done now, you see my Excel, is to put this. We want to also include the data we'll be using for the analysis. So that is
But,
why.
excuse me, empty means what?
It means that we don't have any data included. What we have included here is only the name and year of the study.
Okay, okay.
We have not included the estimates, the characteristics and information about the study. We just have the names and the years of the studies. So there is this one here. I can minimize this. Okay. You can minimize that so that we have okay, so minimize that so that we can see this clearly. There is this other button here, data and analysis. You can click on it, then right click again as we did before. Right click. And you can see here, add comparison. This is the one we take, add comparison. Okay, if you click that, what we have here now is that the topic, as I told you, we are studying this afternoon is to see if there is an association between physical activity, lifetime physical activity, and no physical activity in relation to prostate cancer mortality. That is the fictitious question we are asking. So the comparison will be that we are comparing physical activity versus no physical activity. So you can have something like this. That is what we are comparing. Okay.
I'm sorry. I had just gone to for a short call, so I found when you had just left me a step. So
I didn't get that.
I had included. I had gone through the inclusions of included studies.
Yeah.
I had a list of them. I had finished them.
Yeah.
So I don't know where you click to get this box of new comparison.
Yeah. Are you seeing my window?
Yes.
So see here.
Data and analysis.
Yeah. So click this and right click it.
Okay.
Add comparison.
Oh, okay. Okay.
So you should see this window.
I have seen it.
Yeah, so you can add this. You can make your own shorts, PA versus no PA. So, and we take next. Okay, when you click next, it will ask you, what do you want to do after the wizard is closed? We want to add an outcome. That's what we want to do. So first, the comparison, those who have physical activity and those who do not have, want to add an outcome to this. So you click this and continue. Okay. I will show you something that can happen from here. So these are different outcomes you have. If you go through these outcomes, you can see what happens. It explains. It says here you enter number of participants with events and total number of participants in experimental and control groups. These experimental and control groups can also be exposure and non-exposure groups. And in our own case, we can take it to be exposure and non-exposure group. And exposure are those who had physical activity, and non-exposure group are those who did not have physical activity. So this, if you have dichotomous outcome, in which the outcome is either you have the event or not have the event. In our own case, we have a dichotomous outcome because it's either you die from prostate cancer or you don't die from prostate cancer. That's what we're interested in. So this fits our own outcome. But perhaps when you're doing your own systematic review, your outcome may be continuous, maybe numerical. And so here are those outcomes that, for instance, are mean, standard deviation, and number of participants you include here in this place. This is observed, expected, and the variance. In those outcomes where you have this estimate, you can include here. This is not very common outcome people study, but sometimes it can be there. I've not used this before. And this one is what they call generic inverse variance. Here is a place where you include outcomes that may have standard error. So for instance, the odds ratios that have been calculated, if that is the only thing you have, you do not have the numbers that represent those odds ratios. You only have the odds ratios, the lower confidence interval and the upper confidence interval. Then you include those here. And so in the cases where the estimates have been calculated already. But when you come here, it will require you to have the estimates and the standard error. We'll see how this works. And here is other types of data. I don't know what this means, but yeah, this is what is there. So what we have today in this exercise we are doing fits into this and this. So I will try to show how this works and how this works. First of all, we take this. Everybody here, is there anybody who has any challenge? Okay, let's go to the next. If you go to the next, it's telling you what is the name of the outcome, or what name should the outcome have. We have it, it's prostate cancer mortality. The experimental group or the exposed group is physical, or I put it short form, physical activity. No physical activity. Okay. Then you go to the next. Okay. Yeah, you can see certain things happening here. Certain things happening here. So it's here telling you which analysis method do you want to use? And there are different options here. Because we are including raw data, there are different ways you can use to calculate this. But from what I showed you yesterday, the most common way is the inverse variance. This is the way the meta-analysis we perform the weighting of the estimates of the studies. So this is most common. I will choose this one. These are also used, but less commonly used. And then he said analysis model, and we have gone through this. I know that everyone now knows this at their fingertips. Which one do we use? You think here?
Random effect.
Effects.
Great. So that is quite clear. We choose this one. We forget about this. That is not what we want. Yeah. So depending on what you want to estimate, odds ratio, risk difference. Let's take the odds ratio. And the reason is that, which I can't expand so much here, is that in the studies there we have, I can show this. In these studies, you can see that we have the case control studies and the cohort studies included here. In the case control studies, you can, in most cases, be able to calculate the odds ratio only. You will rarely be able to calculate risk ratio from the case control studies. So you calculate the odds ratios. But for the cohort studies, you can calculate both the odds ratio as well as the risk ratio. So for the sake of uniformity, we use the odds ratio. I wouldn't go into the background into this, but it's quite clear in epidemiology the differences between these two. Okay, so we come back here. We keep it as odds ratio, and these are the only three estimates you can get from here. There are other ones you can also use when you have different types of data. If you have continuous data, you can calculate this too. If you have other estimates, you can calculate also this. Here is indicating hazard ratio, but we don't have those. Okay, so we click next. We click next, and this window comes. Say, which analysis details do you want to use? Yeah, we will want to have totals and subtotals, and this means that once the pooled estimates are made in the meta-analysis, it can include both the total estimate from all studies, and it can also include subtotals. The study confidence interval, 95% confidence interval is the of course the common one used, and also here. Here is advanced option. We don't want this. So we click. Yeah, lots of things are being asked here, but you see when we have the forest plots, we have what I told you is the null line there. So if you are estimating ratios, the null line will always be 1, meaning that there is no difference between the groups you are investigating. Then if it's less than 1 for ratios, if it's less than 1, then it favors the intervention, meaning that there is a lower risk in the intervention group. If it is more than 1, then it means that there is a higher risk in the intervention group. So we can indicate this here. It's saying that if it's left side of the graph, if the estimate is on that side, then it favors physical activity. If it's on the right side, then it favors no physical activity. Okay. Is everyone there? Any challenge?
Okay.
Okay.
Okay. So this is the scale. This is the scale you will see in the forest plot. This is default. We can leave it as it is here because in the forest plot in Raveman, there is a slider you can use to move this in the different directions you want. So we leave this as it is here. How do you want to sort the study? You can sort the study in different ways. You can sort the study by the name, the study ID we have included here. You can sort the study by the year of publication. You can sort the study by the weights given to the studies. Big studies come first. Effect size, maybe going from the smallest effect size to the big effect size. Risk of bias item. Here we don't have it here because this is included when you do the Cochrane. User-defined order. Well, commonly people sort it by the study ID. So we take this one and click next. It says wizard is complete. To edit other properties for the outcome, open properties for the outcome after clicking finish. What do you want to do after the wizard is closed? We can add study data because as you have seen, we have not added anything yet. So let's click this one and see what happens. Now another wizard comes up. Yeah, sorry that we are taking too long for this before our break. Our break comes in around 10 minutes or so because I know that this will take long to deal with this session. Then we'll have some break and come back again to continue. So what happens here is that all the studies we have included have been listed here. And what we want to do is to include the study data here. And so you can Control A to select all because you want to include the study data for all the studies. So click in any of the study and Control A. Okay, then we finish. Does everyone have this window?
Excuse me, Brian, can you please repeat?
Yes.
Yes, please.
Oops. Yeah, so where are you now?
And the wizard. So I have to select the studies and then, yeah, select the studies and then.
Yeah, you select all the studies and then you, I think it's finished or something like that.
Okay, thank you.
Yeah. Urban?
Okay, I've seen it. I almost asked that I didn't get the y-axis skills, but I found it.
Okay, great. Okay, so there is this here. If you bring this like this.
Can you help me? I mean, there's a question. What do you want to do after the wizard is closed?
Yeah,
What's
so
the correct
add study data.
study data?
You
Okay.
see it there? So you finish, and then it will bring you to another wizard that has a list of all the studies.
Yes.
So clicking on any of the studies there, Control A to select all of them, then you finish. Or what button is that? Continue, I'm not sure.
Okay, thank you.
So it should bring you here. Okay. And so you can see this. These are open. These are open, meaning that this column means that we need to input data. It's waiting for us to input data. And if I expand this a little bit, nope, it doesn't help me. This here, it's ready to calculate the odds ratio, and it will give the 95% confidence interval. The IV here is the inverse variance weighting we have chosen, and it's using random effect. And you see here, if you want to change it to fixed effect, it changes. Here, if you want to change it to risk ratio, it changes. Here, if you want to view the forest plot, it comes up. Here is the funnel plot. And if you have done Cochrane review, it will display the risk of bias summary here. And okay, now we want to fill these places. And the first one is the event, meaning that the death, the deaths in the physical activity group. So just follow what I do. I go to the Excel. I show you. So this is the cases or the events in the physical activity group. This one, as I explained before. So you go to your Excel. What I will do here is that I will copy this like this, and I will go back to my RevMan, and I'll Control V and paste it there. I've gotten this. I will go back to my Excel. The total of the physical activity group is this one here. I take this. I copy that. I go back to my RevMan, and I will put that here. Okay. Events in the no physical activity group. I go back to my Excel, and no physical activity group event is this one. I take this. I go back to my RevMan, and I will put that.
It is not working with me.
What do you do?
I made copy from Excel, but I couldn't paste it in RevMan.
Yeah, so what do you do? To copy, you Control C.
Yeah.
Yes, it looks like it is blocked. It doesn't looks like yours.
Oof. Is everyone having the same situation? Is there anyone who is getting it right?
I think that
Yes, the same problem here.
the file is different here. It has T deaths, and then T deaths, and then TN deaths, and not PA PA total.
It depends on what you put there, isn't it?
Wrote, yeah. But it doesn't write it. It seems it's not allowing us to paste.
It's not allowing you.
Yeah, at least for now.
Is it that it's slow or?
No.
We can like
no, we can't paste it.
It's like not editable.
Yeah, you can type, but you can also paste if you copy from the Excel.
Oh, okay, yeah. It's interesting. It's editable too, but okay. So maybe we have to type Pamba, and that's a lot of work.
So
But,
so you just put on one cell there and copy and paste it there.
yeah, I think that's
Okay, sorry about that. I'm not sure how to solve that for you, but I can continue. This is the non-physical activity total here. I copy this and I come to my RefMan and I put this here. Okay. So you can see as this is happening, this is showing the forest plot is populating already. And once I put these values for the studies, it's assigning the weight because it's using the inverse variance based on random effects and calculating this. And then it's calculating also the odds ratios and the confidence interval. If you compare these odds ratios to what we have in the Excel, so you can see that it calculated it right from here to here. So I come here. So this is what we get here. One thing I want to show you is that, of course, we are not going to use fixed effect. But if you come down here, you have the total events here given, but you have the heterogeneity values. You have the tau square, and because it is random effects, somebody is imitating me. It's a mic open there. Okay, because it is random effects model we are using, it has estimated a tau square and is saying that there is some differences in the estimate, and it has estimated this difference as 0.07, and it will use this in addition to the weighting. And the chi-square value it has calculated, and degree of freedom, we have 20 studies there, and degree of freedom is 19. And it has the I-square as a measure of the heterogeneity, and it's saying that 42% of the differences that we find in the studies is due not to chance, but other factors there. And this is the p-value associated with the I-square, meaning that the I-square value is statistically significant. And of course, the z-test value there. Okay, but now we have used random effect. Let me just show you. This is not what we do. We're not going to use fixed effect, but if you change this to fixed effect, it will calculate automatically. Just to show what we have learned. So the tau square is removed because the fixed effect does not include the tau square in its estimation. The I square remains the same, estimate of the difference is the p-value, but the tau square is removed. And the fixed effect, if you come to the overall estimate here, the fixed effect overall is 1.06, and the confidence interval is 0.95 to 1.22. This is the fixed effect. If I change this to random effect, it's 1.11. You see, this changes. And this was 1.22 in the fixed effect, but here it is 1.34. Okay, is everybody here at this stage? We still have the challenge.
Still having challenge of transferring the data.
Okay, sorry, please.
Sorry, Dr. Bryce, I have a question.
Yes, please.
This area where you change to fixed effects and random effects, the OR, that's odds ratio, right? Can we also click on it for the rational, the RR?
You can click for
risk ratio.
Yeah.
Okay.
Yeah. Okay. Then you have risk difference here, but we have the odds ratio. Now, if you want to see the forest plot, you take here. If you want to see it clearly, you take here, you click there where I've just clicked here, the forest plot, and this will come. And you can actually export this. You can export this by clicking here. Here, if you save it, you can save it in the format you want, and you can include it in your paper or in your presentation. I go back, so you can toggle on top here. This is the figure. This is the this window here. I said that the funnel plot is not good. RevMan doesn't like doing it for random effects, so we wouldn't use random. But if you change this to fixed effect, and then you calculate you click the funnel plot. So RevMan will estimate the funnel plot for you here. And this one as well, you can use it and save it for your publication. Okay, this is the first session of this. When we come back, I will take you through other things. And please, sorry for the problems you encounter. They always happen. But the break we have here, the recording we have here, I hope you can have them to go through this again. So let's come back 40. So see you in a bit. 40, we'll continue. Okay, we can continue from where we stopped. So by the time we have done this, you can see that we have finished this really. we have finished this. What we did, I can remove these figures here. I can remove this. What we did here was to use the numbers. To use the numbers here. But realistically, most of the studies you'll be doing will be based on already calculated estimates, the odds ratios, the risk ratios, the hazard ratios, the standard mean differences, the means, and the standard deviations. So based on these studies, I can show you again how we can, what we can do here. So if you come here to this place where we had before, this is where we had this. The outcome we included, or the comparison we included here, was this. And if you expand this, you will see these studies here. I will close this. Let me see what happens. I'll try this. I want to add another outcome here. And this time, the one I have done now, I use the dichotomous option here. I want to use the generic inverse variance, meaning that this estimates, the odds ratios, the hazard ratios have been calculated already. And I'm not using the numbers from the studies, which I did when I used this. So I will use this and make a prostate cancer mortality. Let me call it
Sorry,
2.
Bright, I'm lost. Can you take it again? Is it the data and the analysis that you right click to get started?
You see here, if you click this down, you will get this. Did you get it?
The data analysis, that's
Yeah, the data and analysis. If you click it down, you will get this.
okay.
Yeah. And so this one, right click on it.
Hi, Bright. Sorry, I don't have this part on my system. I do have data analysis, but if I open it,
Yeah.
nothing comes up.
If you open it, nothing comes. Did you get the results we did last?
I did. Let me
Did you get those forest plots and all those results?
Yes.
Okay. Then I guess you should have had it.
I think she has to double click before.
Double click
I also
what?
said
Oh,
double
yes.
click data
Yes.
and analysis.
Yes, I double click it. Thank you very much. Yeah.
Okay. Yeah, mine is just one click. I'm not sure whether 5.4 is different. Okay, so if you right click on this one, you add an outcome and this will come up. And then you will have the same comparisons here. Continue. And if you come here, this was the window we had before. The statistical method is giving you only one options. Before, when we use dichotomous, it allowed us to be able to calculate using this or Mantel-Hansel method or inverse variance. But now it's giving us only one option because we chose the generic inverse variance as the outcome type. So we choose the random effects, and here we can calculate all this. We can calculate all this, but we have the odds ratio we are trying to calculate. So we choose odds ratio. And this remains the same. And here you can enter the number of participants, generic inverse variance for display only. Somebody's asking a question. I'm not sure, to Pista, what could be the problem there, but we can, yeah, we can see. Augusto, you have a question? Augusto?
Yes, right. I have a question. Sorry. How do you open the new wizard?
Yeah, if you go to the data and analysis here, if you click it down, you will get this one we have created before.
Yes.
And under this one, it has this outcome we have created before. But this one is one you right click on this one.
Okay, the physical activity, this versus no physical activity.
Yeah, right click on it.
Yes.
And then you add outcome.
Outcome, and then other data instead of the dichotomous.
So generic inverse variance is the one you choose there.
Okay, generic inverse variance, okay. The next, and then I will use the same name, but I will name it prostate cancer 2.
Yeah, that's prostate cancer mortality 2.
Okay. And the next, okay. And so here I will also continue with random effects, right?
Yeah.
Okay. Okay. Thank you.
Okay. Yeah, any more questions?
My challenge was, I think there's somewhere I clicked, and by the time we finished the first process,
yeah,
of the study groups could not be uploaded on my final spreadsheet.
Yeah.
Maybe there's something that I should have clicked on and I didn't. I'll go back step by step, then I'll get to know. But I'm following now because you're a little bit far away now.
Yeah, sorry.
It's okay.
Yeah. Okay. Let's see where we get to. So now I go next. Favors physical activity. Favors no physical activity. We leave this like this, and we next add a subgroup for, yeah, any question? No, this one. Any question? Okay, not for me. Add study data for the new outcome. Yeah, this is where we continue. Okay, and so if you go here, under this comparison, we have physical activity versus no physical activity. We have two outcomes now. The first one we created, and this was based on the numbers we used. But now we are indicating that we are using already calculated estimate, odds ratio, as you can see when I click here. If you click here, it also gives you the same, but this one, it tells you no estimate. So what I will do here is to select all and click finish. The first one is here. The second one is here. The one we have now. And if I move this like this, nothing is here because I've not included anything. If I go here, I move it, you can see this is what I included before. And what is here on top here is different from what is here because I want to include the calculated estimate. And if I take you to my Excel sheet here, I have the log odds ratio here. And standard error of the log-odds ratio. That is what it is asking for here. The log-odds ratio, this is a little bit hidden, but this is the log-odds ratio, the standard error of the log-odds odds ratio. So I mentioned that I brought this here, this one. I brought it down here because these ones are based on the formula, and I think sometimes it gives me trouble. So I will copy this and go back to my Raveman and put this here. Oof, didn't. What happened? Yeah, it's copied. So I take the standard error, which is this one here. And I put this here. Yeah, you can see what is happening is already estimated. And when I was going through the wizard, this was optional. The total for physical activity, total for non-physical activity, just for showing. It's not using that for the calculation. So I will come here. Total for physical activity is here. I'll put this here. And total for non-physical activity. It's here. Okay, it's looking interesting now. So this is what I have. The estimates are here. And I can check the forest plots. And what I was saying before, the scale we chose before, you see it's up to 100 there. But you can actually make this bigger to reduce the scale. And this becomes bigger. Yeah, so that you can see it clearly. Yeah. So you can add the figure and then save it in the way you want it. And then use it in going forward. Any question this far? I think this is where we have come to now. And I think we'll also be going to exciting parts now. Sorry that you have not followed the different sections I've come to, but I hope you can watch this over or other videos to get a grasp of this. This always happens. Some of the students I had in the past, some have not slept in the night trying to work this through. And yeah, okay, I have 2 hands raised. Who want to ask questions? Please go ahead.
Thank you very much, Dr. Bright. Yes, mine is more of an inquiry and sort of a suggestion. Earlier, you made mention of the recording file being too large. Is it possible for you to give the participants the permission to record by ourselves? So this will reduce the burden on you.
Well, I don't, but you can't record it the same time I'm recording here.
Oh.
You can't.
I seem to have another alternative.
Yes, please.
The Telegram can carry very large size of data
Telegram.
when posted there. Yeah, Telegram. It carries gigabyte size files without rejecting, unlike others.
So how do you send that?
Well, each person, well, if it depends on if you open a Telegram account for this and then you post it there. So everybody will now will be invited to that Telegram account. Just like.
Oh, you mean like a cloud?
No, it's not a cloud. It's like WhatsApp.
Like a WhatsApp group. Yeah.
It's like WhatsApp, but WhatsApp cannot carry the size. So with Telegram, you will invite all of us who will respond.
Yeah.
And then you just drop it there. Each person will now download into their system.
Yeah. So what is required to open that account?
You will now go on, download the Telegram application into your system.
Into my computer or my phone?
Anywhere, whether your phone or your computer, you just download. And then you will invite all of us.
You will create an account.
You create an account. You will now invite all of us, and we will accept. And once we accept, we have access to that folder, and then you just upload the recordings to that account, and everybody will have access. Then we can now download into our system.
Yeah.
If I can add, it's either you create a group or a channel. So
can somebody do it apart from me, and I can just put it there?
Yes, that's possible.
Yeah.
It's possible. Yes. Yeah, it's possible. They will now invite you.
Yeah. Then I can put it there. Anyone wants to volunteer?
Like volunteer to do that.
Yeah. Is that possible? Yeah, you can do that. I'm not familiar with this Telegram, but I'm happy to put this files there for sure.
All right, that would be very nice.
Yeah.
Thank you. Thank you, Professor.
Okay.
Yeah.
I think another thing should be, if possible, if the file can be reduced to an extent before it is being posted there, because of internet issue with, we are in Africa, so if possible, if it can be reduced to an extent before it can be posted there.
How do you, except editing?
No, I think there are, there are some software, yes, that can compress.
Software that can compress, yes.
Yeah, they just compress to an extent.
You can compress it.
Well, I would try to see that. I don't know what happens to the quality.
Yeah.
It shouldn't affect the quality to an extent.
It might,
because
we'll be reading on screen. The letterings and the alphabets on the screen might be really compressed that we can hardly make out what is written there.
But if the Telegram is carrying big files, then it shouldn't be a problem, isn't it? To just put it there.
I've used Telegram to move videos.
Okay.
Videos of 2 gigabyte, 5 gigabyte, 10. But the maximum we can get from WhatsApp is less than a gig.
Less than 20 MB.
Yeah. And
then when I checked the first day, the video was more than 400 megabytes.
And that's still reasonable.
It's still less than 1 gig.
Yes,
it's just 0.4.
That's
reasonable.
Posted on Telegram.
Yeah.
Yes. And we should be able to.
Okay. Posi, you do that, and then you invite all of us. I will put it there.
All right, no problem.
Okay.
Now, I wanted to ask a question.
Yes,
maybe the forest graph that we are seeing, forest plot we are looking at now on screen. It says on the left, it says favors physical activity. On the right, it says favors no physical activity. Now, is there any implication of those studies that fell on the left, on the right side? Is there any implication because there are more studies falling on the left side and fewer on the right side or the left side? Is there any interpretation of that? That most of the parameters are on the right.
It applies some which in like no care distance. Is it something that can be?
I made this. Okay, Prof. I think as I said earlier, this is demonstration. So whatever finding we have here does not have any meaning.
Okay.
But if
Just-
this
just
is in
thought
real,
like that.
yeah, if this is in real life, then we will begin to find a way to interpret what this may mean in real life. But these numbers are just fictitious and
Fictitious, okay.
yeah. But the next step I want to take you through is that if this is real life and you see this, what do you do? That is the next question. How do I interpret this? What can this mean? Can this be real, or there are other things that are happening in these studies? So that is one thing I want to take you through in the next section now. And some of the things we have gone through today. We went through the, what is it called? We went through the subgroup analysis. So that is one thing we can now try to do in this section now, to see whether there are factors, because you can see when I did this, you can see what happens here. You can see that there is a large amount of heterogeneity, and this is statistically significant. So the question we may want to ask now is to try to understand what could be causing this heterogeneity here. So since this is done, I have shown you how you can bring in this when it's numbers or when it's odds ratios or calculated estimates. So we want to divide these studies by subgroups. So let me go with this here. Are you seeing here? So if I go to this outcome, the first one I made before, if I right click it, if I right click this, this will pop up here. And there is a button here, it says introduce subgroup. So if I click this, it is here. So if I click this, it has given me the new subgroup I have introduced. So I go there again, and I can take add subgroup. You see this outcome. The first time I clicked it, it was introduce subgroup. And when I selected that, it gave me this. So this one, it has given me, it has taken all the studies now to this new one. I go here again and I add subgroup. Okay, and it will allow me to give a name to that subgroup. Just watch what happens here. So what I want to do now is that if I go to my Excel, I want to do this. These are different characteristics of the studies that I would like to evaluate, how these characteristics may influence the results. So I will start with the study design, and there are case control studies and cohort studies. So I go here And I call this perhaps case control studies. I finish, so it is here. So what I will do here is that I will change the name of this one and call it, oh no, rename. I will call it cohort studies. Okay, so you see what happens? But what happens is that in the case control studies, there are no studies here. We'll have the studies only in the case control studies. So I will go to my Excel here. I will go to my Excel and identify the case control studies. And that is the AHS and Allen and this and this and this and this. So there are about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 studies. So HS Allen, I try to work on this and go one by one. So what happens is that because all the studies are in cohort, I will move those that are case control to the case control side. So I move this here. So it's moving. This goes here. This is also a case control study. Check. Then I have Ewings, Freddie Rich, and Gadiran. So I move this, case control, move this, this. A few more. And I have Hayes, CA, Lifespan, and oh no. Okay, so let me expand this so you can see what happens. I have divided the studies into the different subgroups here. Is that okay? So if you want to create the subgroups, this is what you do. You create the subgroups in this way. Sometimes there may be 3 subgroups. There may be 4 subgroups. We'll come to see. So if I now come here, once I am doing this, this section is updating as well. This section is updating. So let me take the forest plot so that you see what is happening here. So with this, before they were all together as one group of studies, but now we have divided this into cohort studies and case control studies. And for cohort studies, it has calculated the estimate overall and the heterogeneity estimate. And for the case control study, it has done the same thing. And then overall, it has the result we calculated before. Yeah. So many questions. Well, let's see what happened. Okay, So it's already done, eh?
Yes.
Okay.
Yes. Towards the end of the day, and everybody can join then. From there.
Okay. All right. Thank you very much. Okay, so I will check that afterwards. Now you can see that the studies have been divided into the study designs, cohorts, and case control by what we have done here. And what is interesting is that let's go back to the forest plot. This is the overall for the cohorts, and this is the overall for the case control. What do you see here? Any observation? Any observation in all this?
I'm looking at the homogeneity and heterogeneity of the course and the case control.
Yeah, what do you see?
Am I correct?
I didn't get what you said, Bossy.
The heterogeneity of the codes and the homogeneity of the case control.
Yeah, what do you find there?
What do you see? The question.
The case control seem to be homogeneous and cohorts is heterogeneous.
Yeah, is that
correct?
Yeah, you can see that both of once you have divided both of them, the I square values are very low, very low. They're very low. When you put them together, they were 42%.
43.
But once you have divided them, this becomes 3% and this becomes 0%.
0%.
You understand?
Yeah.
And so what it's saying is that if you combine these two studies that are of different designs, they appear to be heterogeneous. And that is right, because case control studies we automatically are different from the cohort studies.
Cohort studies.
So you can see this showing here. And so when we separated the case control studies from the cohort studies, we can see that the cohort studies appear to be similar to themselves, and case control studies appear to be similar to themselves, and that is reflected in the I square we see. Okay, any other observation? What do you see with the overall estimate?
Skewed.
You see, this is odds ratio, meaning that the core studies have 0.81 odds of those who partake in physical activity have 0.81 or about 19% reduced risk of having of dying from prostate cancer. But in the case control studies, you have the odds ratio is increased, meaning that if you do physical activity based on these studies, you have 45% increased risk of dying from prostate cancer than those who do not.
I'm hearing you. I think we talked to.
Did you get the point? So the case control studies are showing increased risk of dying from prostate cancer when you engage in physical activity. Why the cohort studies are showing that if you engage in physical activity, you are less likely to die from prostate cancer. Is that clear?
Yep.
So what happens here is that this was the overall effect we got before. But when we stratify or when we did by subgroup of study design, we see that the case control studies are exaggerating the effect, showing that physical activity is actually a risk factor for dying from prostate cancer, why the cohort studies are. And so for you now, what's, if this is a risk study, what will be your concern? What will be your conclusion from this?
Yeah, right. There could be a number of issues.
Yeah.
Maybe bias with the case control study, recall bias and other biases.
Yeah.
If we assume that the core study is a bit superior because we measure in the from exposure to the outcome rather than from the outcome to the exposure. So recall bias will be minimized in the core study, but here it could be that there is some recall.
Yeah.
But I had a little. I was looking at the diamond plots for in the individual studies in the cohort study. A couple of them are also showing the elevated risk, but I think the 1, 2, 3, 4 has 5 actually has pulled this one to this side.
Yeah.
So I don't know. Whereas in the case control study, all of them are having elevated risk.
Yeah. You know that this is weighted average.
Yeah.
And so once we weight this, our concern will be.
This should be on this, yes.
Yeah. So the average behavior is around this, where the average behavior is this. This is not a real study, but you may encounter this. The point we're making here is that if you get this, you shouldn't run to the press to say this is what is happening here. And see, now we have done the subgroup by study design, and we can see that something needs to be looked at that is happening in these studies. So which one do we believe? And so what you do is that you can go further step. We have looked at quality appraisal of the studies. And so now what we can do is to see whether there's difference between the studies in terms of their quality. That's one thing we can do. And so we would like to do that. And if I go to my Excel, you can see that we have the quality of the studies here. Let me bring this closer here so that it is easier for me.
Dr. Bright, maybe just hide the columns that we don't need right now.
Yeah, so how do I do that?
You have to, select all the columns that you don't need. Yeah, and then right click of the mouse and hide.
Hide them. Okay, great. So it solves my problem. This is what I want. Okay, so now what I would do is that I will go back to my Revman, and you see the files I put in the Dropbox. I have made these files into different of those characteristics by study design, by quality. So if you just click any of those files, you will get the same thing I have here. But what I would do is that I will go here and I will add another subgroup. So I call this low quality. studies. Yeah. Then I go here, I will rename this, I call them high quality studies. I don't need the study designs anymore because I don't have space to do that. That is one thing here. And this one, I will call it, is it medium they call it? No. Medium quality studies. Okay, so I will now move. Let me go and see which ones are low quality. Is this? Okay, I have AHS, ATBC, Evans. So I have Hartman, Joseph, Lifespan, and Walker. Hartman, Joseph, Lifespan, and Walker. Okay. So I go and get the medium quality studies, or moderate, actually, call it moderate. So I can change that. Moderate quality. So I have AHS 60, Carrot, Friedrich. Moderate. Oh, it's there. Okay. So I have highest King, Ordner, Weinstein. And the high quality ones are Allen, this, Gadarian, this, Allen, CA, Gadarian. Allen. CA, Lee, and Sver. Okay, this is all we have. So these studies now are put into the quality. So this is moderate. Yeah. Okay, you see what is happening? See what is happening here? So we have the high quality studies, we have the moderate quality studies, and we have the low quality studies. And so we can see by this how the estimates are. The high quality studies are showing that there is some increased risk, although this is not statistically significant because the confidence intervals are including 1. The moderate quality studies are also indicating some increased risk, not also statistically significant. And the low quality studies are showing a protection of physical activity, also not statistically significant. Did you get this? Everyone is quiet.
But we are here.
I think we are following, and at the same time, the law of diminishing return is setting in.
Right. It's coming in.
I think we can have some bits of break.
I have questions.
Yeah.
Questions.
Yeah.
So how do we think through the appropriate sub studies that we need to extract from?
Yeah, the subgroups.
Yes.
Yeah. So this one
So
we are doing.
Start fishing.
Yeah, so this one we are doing now is the quality, and I mentioned it and
Quality
I emphasize it that the subgroups need to be specified when you're developing the protocol. It needs to be there. You need to say we will analyze, and this is based on the knowledge of the topic. Yeah, so the subgroups need to be identified at the beginning. The subgroup can be thinking alongside the intervention. For instance, if we go here, we have the subgroups by what's it called? By region here.
Region, yeah.
So if you're thinking of intervention, it is possible that once you have looked at this, you may consider that, for instance, prostate cancer is more prevalent in the non-European countries than European countries. So it would be good if we find anything related to physical activity to initiate intervention there, physical activity related intervention. So you can think along that side when you are planning the study and then indicate the subgroups you'll be doing your subgroup analysis. So you do that before the study. And of course, the yeah, diminishing return, the children are crying for help now. Yeah, I will set you free soon. I will set you free soon. But is this too complicated, or you're following what is going on here?
No. This is exciting. I mean, this is.
It is really exciting as long as we practice.
Okay. Well, I don't have so much to show than to show you that this is how you organize the subgroups, and you can investigate that. And then we have other subgroups you can also investigate here. But the same way we have done this, you can.
No, you must give me email addresses, and then I send to them.
Okay, so what's your email address? Then I will forward the
Email address of the recipient.
Yes, the recipient.
Somebody is not muted.
Yeah, I met him. Okay, so this is the way it works, and you can practice this by yourself. The video will be there, and then I think you get it right. So what happens is that I can stop here, and then you can take some break and go to your breakout rooms. Is that okay?
Yeah, but oh, sorry, Dr. Bright.
Yes, please.
Okay, so I'm just thinking, is it possible we have the video of today's class? Because I came in very late, actually. I've been trying to follow up, but no, I'm enjoying this part, but the earlier parts, how to even bring the file into the RefMan and all the rest. But once I have the video, I should be able to do that. So
Yeah.
if the Telegram is being created today, I think if I get the video, I should be able to do that before tomorrow, so that I will be on the same page.
Well, I would try to do that. What happens is that the Zoom will convert the video only when the meetings are over. You
Okay.
understand? It is recording, but it will process it once the button is clicked, meeting ended, then it will process it. So it takes some time, but I will try, once it's ready this evening, I will try to upload it to the Telegram.
Okay, thanks for that. On the Telegram issue, I think we'll have to give the person our numbers to be able to do that.
The
Possible. What do you need from
link
them?
has been invitation link has been sent to the chat room. I will
Okay.
send it again. You can easily just go through the invitation link.
Oh,
Some
okay.
have already joined, so I'll just send it again so that in case you missed it.
I can't see it on the chat.
It's on the chat. He sent to the chat.
I'm sending again now.
Okay, now I've seen it. Thank you.
Okay, let's take some break and join the breakout room at 45.
Right, a quick question. How do we, this data is saved already, or we have to save it somewhere in the software?
Yeah, you have to save it. You can save
Okay.
This here.
Okay, we just save it, okay, yeah.
Yeah.
So if we don't save it, everything is lost, right?
Yeah, but the files I gave to you, those files contain all this. Now, also the subgroups in those files.
Oh, okay.
The files you take from the Dropbox, you will get all this there.
Yeah. Okay, thank you very much.
Okay, please don't go out. I will put you in your groups so that once you come back from the break, you join your groups. And then, yeah, please just a minute. One thing I want to highlight this is this afternoon, you can work on this or continue wherever you stop. I will pass through the groups, and if there are questions, I will help out where possible. Okay, see you in a bit.
What is the name of the group on Telegram, please?
Please, how long is once you click on the link, it will just take you there automatically.
No, what is it? Is there no name?
The link is in the chat, please. Once you click on the link, it will take you to your Telegram application if you have the application installed on your phone or on your PC. So the name of the group is SR and MA course, Afrikaans course, just like the course name.
How long is the break time?
45 will return. 15:45
Oh, okay.
here. I think it should be 14:45 in Nigeria.
Oh, no, I said she has the key to the Jeep now.
Okay,
So
thank you.
she may not work in here.
We already have 10 participants subscribed to the group. So if you don't have the application installed,
All right, so have a safe trip. Yes.
I will advise that you install it so that by the time the video is uploaded, yes.
It's asking me for code.
Code?
Yes, that's for code.